Hey, we are live today on Monday, the 26th of February 2018. So far on the panel, we have Yudit from Israel, Astral from, English from Denmark. We've got Jay from America. We've got Patricia from the UK. We've got Levkungfu from the UK. We've got Artist from Germany and our special guest, John from America. Hello.
Evening.
Hey.
Good evening.
Anyway, good evening, Yudit. We've asked John to come. John to come on because he has done a lot of experiments, haven't you, Don?
Yes, I'm still here.
Yeah, you've done a lot of experiments, and obviously this Stan Meyers one. Would you like to explain a bit about all that? Because obviously you came just before Christmas, but because there's lots of twists.
Stan Meyers was a private inventor in Grove City, Ohio, which is right next to where I'm at in Pennsylvania, about 4 hours from my house. And he started experimenting with hydrogen produced from water through a process everyone's familiar with of electrolysis, separating the water into its hydrogen and oxygen components. And he decided to use that energy from water to be able to power a car or anything else that relies on petroleum-based products. So he started his quest right after the oil embargo that was on the States back in the mid-70s, and he felt that that was something that no country should have that kind of power over another country. So he set out to try and find an alternative energy source, and he chose hydrogen from water. So from then on, he started experimenting with the normal electrolysis, separating the oxygen and hydrogen from water, and then you could turn around and burn the hydrogen as a fuel source. But the process is very slow, takes a long time to produce enough gas to do any good. You'd need a really large scale facility to produce lots of gas. But the gas that's created with this process is extremely volatile because it's a perfect mixture of flammable fuel with oxygen. So it's literally, if you make this stuff and keep it in a sealed container, it is a bomb. It is not a separate component of hydrogen and oxygen. It's a perfect blend. So all it takes is a small spark ignition source, and it will detonate. And then it detonates at such an extreme force, it's volatile. So he only wanted to create a gas on demand. So there was no storage of the gas needed to do it, like taking your car and getting it filled with petrol, as you guys like to call it, gasoline. This would produce the hydrogen, oxygen on demand. He'd run it into the engine, burn it, and the byproducts of the process was water vapor. So it's environmentally friendly and clean. So you're basically using the energy, making water, which in turn, if you could recapture it, you could re-electrolyze it, put it back in the system, almost like a closed loop system. But because water is so plentiful and when it rains, it's free, you didn't need to do that. You just use what you had, convert it into gas, burn it, and on you go. So that was generally where he was started. And in his research, he went through multiple levels and layers of refinements to where he got it all the way down to a simple little, looks like a spark plug he called a water fuel cell injector that could be used to replace a standard spark plug in a car. It would be used as an actual injector for the hydrogen gas. It also would inject exhaust gases would also be injected in there to slow down the burn rate of hydrogen, because hydrogen doesn't burn, it explodes. It's such a fast burning material. So you have to slow it down to make it usable in any kind of automobile. And then the fuel injector was also a spark plug that would create the spark at the correct time to fire it, just as if it was like gasoline. So that was basically from start to finish, and he had many systems and designs in between that. And then he also extrapolated from there to use it for household heating. You could use, if you had a furnace that used natural gas, propane, or the likes, you could burn this hydrogen fuel as well. And then in his research, he also discovered that he's able to extract electricity from the mix while he's making it too. So now he's producing electricity from water as well. So he had many ideas and variables that he was able to perform with this electrolysis process. A standard electrolysis requires a DC voltage if you're not familiar. If you just take two wires, hook one to a positive and negative of a battery, drop them in a glass of water, one of the electrodes will put off hydrogen bubbles, the other, what you would call electrodes, wires, would produce, one produce hydrogen, one produces oxygen. And then they both come out of the mix equally as a 2-to-1 ratio, 2 parts H2O, so it's 2 parts hydrogen, oxygen, and 1 part hydrogen, excuse me. So you could then capture it, burn it. So where was I going with this? But yeah, he used that process to also generate electricity, but he could use it in home heating, industrial, where anybody needed gases, fuels for melting metals, making metals, and then he also used it to. He had his last idea was a hyperloop system for submarines to power submarines. It was a silent propulsion system, kind of like the movie Red October had. So, but he had many ideas, and it seems like when he would work on one idea, he'd come up with another, and then he would jump onto that without really finishing, because he figured if this worked, then this will work, then this will work, and then just snowballed from there. And so he was doing a lot of things, and he was also looking to use it as a fuel source for aircrafts. So if you have like modern day aircraft accidents, runway mishaps where the plane might strike something and catch on fire and burn down, if you're using water as a fuel source, there'd never be any fire because there's no stored hydrogen in the process. It was all made on demand. That's where I was going. The electrolysis requires very low voltage, like 1.5 volts, to produce the gases, but it's so slow and so small amounts. So the normal thing would be to just keep adding more current to the source. The more amps you put in, the more gas it puts out. So you increase the voltage, increase the amp draw, you produce more gas. But in the long run, what that does is you end up with this like exothermal acceleration of heat. It just goes exothermal and it gets hotter and hotter and hotter, and then the efficiency of the process keeps dropping and dropping, and you end up making a lot of steam instead of hydrogen. So, but his process he devised a way to use high voltage at very minuscule, very low um, current draw. So he was reversing the process. Instead of using low voltage, high current, he was using high voltage with low current and producing, 1,000 times more fuel with the process. So it was a complete opposite turn on Faraday's electrolysis. But that's kind of it in a nutshell.
And then something happened, didn't it, Don, with him?
Yeah, back in '98, just right after he signed a contract with a couple foreign investors to build the plant, they had the plans all drawn up and the property. I'm pretty sure he purchased property to build a plant to start to go into production of these systems. They're out celebrating that night with these two Belgium investors, I believe they were, and he ends up having a brain aneurysm and dies in the parking lot. Is the official story. So while they were out celebrating this joint venture, he ends up dying right there on the spot. So some people believe,
Were you going to
say that he was
contact him as
poisoned.
well? You were thinking of getting in touch with him, and then he died. Is that right?
No, I never met the guy. I came into this whole thing, how many years later? 2000 and it was probably almost 10 years before I ever heard about Stan Meyers' name. When I started researching hydrogen myself, I came across a site called the Water Powered Car, and I was scrolling through the different stories they had there, and Stan Meyers' Doom Buggy showed up, and I remember seeing a video when I was at the Oshkosh Air Show around the late 90s, see, it would have been, what year was that? Around, I want to say it was the late 90s. I met a guy there named Rick Schneider who was working with Stan Meyers at the time, and he was going to be the front man for the aviation market of Stan's research, of Stan's products. And then there was going to be one for home heating research and products. And then there was the automotive. So he was setting up different tiers of the business. So, and then this guy had thrown a videotape in with an old VHS tape, because this was before CDs and stuff. And he showed this buggy, but he never said Stan Meyer's name. He just said he was working with this company in Grove City, Ohio. And then I come home and I never heard anything about it again until I come across that water powered fuel website. And then I started looking at it. I was like, that's not that far away. And I was like, that's the guy he was talking about, but he never said Stan Meyers. But it was the same person. So then I started digging into it. And then I got to the point thinking, I wonder, no one's ever talked about this buggy after the death of Stan. So I'm thinking, it's got to be around somewhere, and it has to be out there in that neighborhood. And because Stan Meyers was such good friends with Charlie Holbrook, I figured that would be a perfect place to start. I actually came across a news article from the Columbus Dispatch that was talking about the story, and this reporter had went and met Charlie Holbrook, but he didn't give Charlie's name. He just said it was somebody who lived south of Grove City where Stan was. And then he got to see the buggy, but he wasn't able to report on it because Charlie wanted to keep it quiet. And then when I started looking for it, I didn't know at the time, but Charlie died like 2 months before I started this search. But it took me like 2 months to find it, only because I was asking for help from people that lived in the area. Say, hey, can you go check on this? Can you check on that? I was contacting anybody from the area to see if they could help me with this search. And in the end, I end up just calling the operators. Over here it's 555-1212 information. I just asked for any name for a Holbrook that was in the phone book, and they gave me a phone number, and I called it, and they didn't say who it was, and it turned out to be David Holbrook, which was Charlie's son. And I says, hey, I'm just trying to find this buggy, that everyone's talking about. And he goes, well, I have it, and that's pretty much it. So then over the coming months, I just kept calling and talking to him. At that particular time, he was trying to find someone to buy everything out from them so he could get rid of it. He was tired of having it. So the family, wanted some money, and they were just looking to sell it off. And they also wanted, a piece of the pie if it was ever figured out. So when I first called David and talked to him about it, he was kind of reluctant to really say much. He said, well, give me a call back in another week or so. And so I did. I followed up, and then I just started calling and talking to him. And then he finally was like, would you like to come down and see the stuff? And I was like, well, I sure would. So 4 hours later, I'm down there seeing everything first time. And he was kind of reluctant to let anybody take pictures of stuff at that time. But the more I associated with Dave and befriended him, he finally let me have some access to the equipment, because he knew nothing about the technology. And he's like, well, here, why don't you take this home and, see if you can figure out how it works. Because he figured if I could figure out how it works, then they would have something, worth selling, get more money out of. So he started letting me bring stuff home. And then that's where I documented everything, took all the pictures of everything, and as much as I could of what I had. So, and then from there, the rest, I pretty much put all that stuff out there to the world. So without everything I did, nobody would even know where the buggy was.
Well, glad that you did that for everyone, because obviously, where did it go then?
It ended up in Detroit, Michigan. A company up there goes by QCI. It's Quad City Innovations, which they were already into water fuel research, as everyone likes to call it. hydroxy, HHO. A lot of people call it different things, water powered. But they were building these industrial size electrolysis machines, which were just strictly Faraday's law electrolysis. They were using, high voltage, 220 volts through stainless steel plates and things, and they were producing gas. And what their goal was to take these machines to manufacturers, companies that use natural fuels, natural gases, and stuff to make their products with. So what they would do is they were doing a sales pitch that they would install this machine and it would be used as a supplement, because if you use hydrogen with a normal burning source of gases, it will enhance the burn, cleans the burn up, and makes the burn more efficient, which in turns allows you to use less of the fuel source, the main fuel source. And this company had told us that the government came in after they heard about it and told them, says, we won't bother you as long as you don't go over 70% with your product. They didn't want them to introduce more than 70% of this HHO gas, because they don't want you using it by itself. They know its power and its potential, so they're telling them, as long as you don't go over 70% supplement, we won't bother you. If you go over 7%, then we're going to come in and shut you down. That's what they told us. But they were already into the marketplace, and their goal was to supplement the gases used with this HHO mix. And then for the equipment, they would take and only they wouldn't charge you for it, but what they would do is any money you saved on your fuel cost, they were getting a percentage of that savings and cost. So it was kind of a win-win for the company, and then they would get paid money, and the company didn't have to pay for the equipment. They just reap the rewards of the efficiency of less fuel burn. So that's what they were into. And then they came across this stuff being for sale and decided to put in a bid for the offer to get everything, and they ended up winning the bid for the contract, and then they took it all off to Detroit, Michigan. At one time I'd heard that the company had moved the stuff into Canada somewhere, but I don't know if that's true. That's just what I've heard a couple times. So it's since it's been moved, nobody's really seen it or has taken any pictures of anything since then.
That's not good then, is it?
No, they kind of want to keep it close to their chest. But a little bit of information has been released, because I've been seeing people.
Find out, do they? They don't want the people finding out all this stuff, do they? And doing things for themselves.
No, they want to corner the market, so to speak, with it. They want to be the ones that bring this thing out, but they're having troubles figuring it out. A lot of Stan's stuff was gone at the time, because when I went through the everything that the Hallbrooks had and the stuff I've seen on the internet, there were components missing. There were different types of test demonstration cells, the EPGs, and a lot of the stuff just wasn't there. Somebody had either taken it out after Stan died, or Stan got rid of it because it was old stuff. I don't know. But there are a lot of components missing, and I don't know if Stan ever kept the records. If there was some small piece of the process that was the key to making the systems work, he may not have documented it. It may have just been in his head, and he knew how to use it, how to make it work. But someone had told me at one time that everything that Stan had there in his possession, that if someone was to break in and steal it, the system wouldn't work, because he never had an operating system setting there that would be vulnerable to being stolen. So he always had it set to where it wouldn't work, but it could be made to work by him. That was one of the stories.
And it was also not on the patents he got.
Yeah, he gotten, I don't remember how many patents, but there was a bunch of patents. And when I went through all of Stan's stuff there, one time Dave calls me down so we could try to go through everything and see if we couldn't find that information. He showed me all the patents. He had every copy of every patent that Stan had, and the plaques and stuff for Inventor of the Year. He still had all that documentation. And then all the computers for the whole systems were all still there too. They were all Apple computers that were networked together. And tons and tons of...
So I was going to ask, do you have any of the photographs still that you took?
I have all the pictures that I took of the equipment. I have pictures of all the stuff when the Orion project showed up to look at it, to make an offer for a bid to buy. They took tons of pictures, and David gave me a copy of all their pictures. But everything I have is what's on the internet of all the pictures of everything, all the components is basically what I have. The only pictures I did not release that I had were pictures with people in them. The people from the Orion projects, because they took all these pictures that had people's faces in it, and I just didn't release those because they weren't pertinent to the data. I wasn't going to throw people's faces out there. I just held those back. But most people know who they are anyway. Their pictures are on the internet because of the Orion projects. They were the board members.
I wanted to ask you a bit about your experiments that you've been doing, but I just wanted to ask you, what did you make of SpaceX car then?
Yeah, just like he says, it looks fake, and I think it's all fake myself. I mean, I can't see that it even looks real. There's, like I say, there's problems. They tell us that the temperature of all that space is so hot, and I'm not sure if those Tesla Roadsters are metal or fiberglass, but any of the interior parts, the tires, they wouldn't be able to withstand any kind of temperatures like that. Especially if the tires, unless they put holes in the tires, they surely would have just popped. Or any kind of, it's an electric motor car, transmissions, it still has fluid and everything in it. There would be all kinds of problems with things popping and burning up.
Well, none of us believe it's real, I'm telling you.
No, yeah, I'm on that same boat as you folks. I don't believe it was real either. It looks so fake. It has to be real. Is just so wrong.
Do you mind explaining? Because obviously we're older and we're wiser now, and some of us have woken up and so forth and that. But do you mind explaining a little bit about what you used to do as your career?
Right out of high school, I went into the Marine Corps. I went in under a predetermined contract to be an aircraft mechanic. So once you graduate from basic training boot camp, then they send you off to the school that they promised to send you to. Now, I didn't specify, I wanted to be a jet plane mechanic. Um, but I just wanted to be a mechanic, so I want to be an airplane mechanic. So based on my SAT scores and ABABS test, they determined that I would be good for a mechanic's position. So that's all they guaranteed, was that I'd be an aircraft mechanic. And so I went through boot camp, went into the aviation training to be a turboprop propulsion mechanic is what it's technically called, but it's a jet engine driven propeller airplane. It's a C-130s, which are real common, 4-engine jet engines driving 4 big propellers. So I did that for 4 years in the Marine Corps as a mechanic. And then once I got out of there, I went to the local airport here in Erie, Pennsylvania, and got a job working there as an aircraft mechanic for the next 5 years. And then once I left there, I ended up going into industrial maintenance, because I was at what you would call a FBO. It's a fixed base operator. That's where people with small light aircraft would come in and get their airplanes serviced, oil changes, tires, brakes, any problems with the small aircraft, small corporate jets and things like that. And then they did charter service too, where you could charter an airplane and have a party taken out and back. So we serviced all those types of planes and fueled all the airliners at the time that would pass through Erie International Airport. So we have the life flight type helicopters that were on service, so we'd fuel those and all that. So I did all that stuff for 5 years. And then I left that field and went into industrial maintenance. I took a job as a maintenance guy for a shop called Snap Tight. They made fire hose for fire trucks and stuff. So it's like they were one of the biggest fire hose companies in the United States. They're still only one. They've sold out since then. They're under a different name, but there's only 3 major companies that make fire hose. So I did that for like 9 years. And then after that, at that time, towards the end, I was messing around with cars ever since I was in the service. I was a Ford Mustang guy. So I did a lot of souping up Mustangs, cars, mechanics, because I just love mechanical things. I'm very mechanically inclined. So I started playing with the Mustangs and got into drag racing the Mustangs. I got all the way up into the part where I bought a dyno machine for dynamometer test machine, which was called a dynojet. You'd strap your car on there and run it up through the gears, and it would record your horsepower and torque readings of the car. And then I would tune the cars, whether they were carbureted or fuel injected. I had software for reprogramming the fuel injection systems in the car to get maximum power out of them and stuff like that. So I did that for many, many years, and then I sold it off and ended up buying this house I'm in now. I ended up getting out of that because it really was pushing to the side my true love, which is flying. But ever since I got out of the service, the first thing I built was one of those gyrocopters. The videos that are on my YouTube channel now is my last generation, my third different type of gyrocopter I've owned over the years, over the last 30 plus years. So I've been always loving airplanes, but the cars was kind of pushing the airplane stuff to the side all the time. And so I finally decided to just quit it all and get right back into my true love, which was airplanes and flying. So I've been building the planes, and I've got the two-place white and green plane. If you see it on my YouTube channel, it's a CGS Hawk. It used to be what was classified as a experimental trainer for ultralights. It was an ultralight trainer, and then the FAA decided to get rid of that category and go with made everyone put those planes into the experimental category, and then you had to have the N number, registrations, and license, and all that needs to go with that. So it's still considered like a two-place ultralight, but it's a legal registered aircraft that I fly now until I get this last project I'm working on now. The
Yeah,
Corsair.
you're making a plane, aren't you? You're
Yeah,
making one.
Yeah, I'm building one from scratch. The little green and white one, that was a home built plane too. It's just aluminum tubing all pop riveted together, covered with like boat sailcloth. It's all sewn into covers and it's stretched over and attached. So it's the lightest version type airplane you can build, but it was a kit. I just bought it from a guy that had built it, but it was a home built airplane. And then the one I'm building now, see that two-place only cruises like 60 to 80 miles per hour. And the one you see in my videos now, that's the foam fiberglass composite, the World War II replica of a Corsair. That one there is 3 times faster. It'll do, 150 to 200 miles per hour.
Don, just for good measure, this is your channel with 3 videos only at the moment.
No, that's my second channel that I started just for flat Earth stuff that I haven't really put much on there. But you have to go to Dynodon64 for all my other videos.
It's in the description.
Yeah, that's where.
Okay, cool.
Yeah, that's where my Stan Meyers experiments are, and all my airplane stuff's on there.
His channel's in the description on this Hangout.
Yeah, that second one, I've had that channel, but I've never really used it. Somehow I ended up making 2 channels, but that one, with my name, Don Gable, I put that on there, so it's only going to be associated with my flat Earth stuff. And I try to keep the other flat Earth stuff off of my other channel because people are there to see my projects, my airplanes and stuff, and I just don't want to mix the two. So I started the other channel or added to it.
Yeah, that's understandable that you do it separate. And this is his other channel, Dynodon64, so people can see how it's written, how basically it looks. It's also indeed in the description, and I also will put it in the comment section so people can click on the link.
Yeah, and then when you click on the video section, you'll see the list of all the videos, and you'll scroll down and see some of the Stan Meyers experiments and research that I was doing there.
Yeah, indeed. If you click on it, you can see all the experiments he's done.
Yeah, all the ones with the oscilloscopes. That's the Stan Meyers stuff.
Yeah. Do you want to explain a little bit about that?
About which part?
Well, your experiment right now is you're trying to make this. Well, you're finishing off this aeroplane, but before that, you were doing this, weren't you? The Stan Meyers experiment.
Yes. There's, like I said, Stan had done several different variations of his work. The original ones that started the process was what he called his demonstration cells. If you've seen any of Stan Meyers' videos, it's the plexiglass clear plastic cylinder with the multiple tubes in it, and then it's hooked up to an alternator that's being driven with a electric motor. He plugs in, he turns on this black box and turns up a knob, and then the gas starts being produced. That was his demonstration cell that he used to prove his concept of voltage over amperage instead of amps over volts. And that's the demonstration unit that he used to get his first patent on this process. So everybody's been trying to replicate that particular demo cell, which is not his. See, Stan had two different types of units. This was a amp restricting unit, meaning he was trying to restrict the amps back. If you're familiar with the law of electricities, you have voltage and current and watts. So amps times volts. So if you say you got 100 volts and 10 amps, you have 1,000 watts of power. Okay, so what Stan was doing was he was using that same 100 volts at 10 amps and he was reversing it. So now he's making it 10 amps at 100 volts. And then by doing that, he was restricting the flow of electricity. If you can, to restrict the amperage, if you can keep the amps from taking over and doing what he would call a short. He was basically creating a dead short. When you try to apply a lot of voltage to water, it just shorts out. Water is really conductive. Natural water is highly conductive. So you can't put high voltage to it. It'll just revert to amps. It'll suck the voltage all the way down and pull a lot of amperage. So this first demonstration unit would take that voltage, and he was restricting the amps. And as you restrict that amperage, the voltage starts climbing because it's the same power. If you put in 10 watts at 1 volt at 10 amps, you have 10 watts. But if you put in 10 volts at 1 amp, you still have 10 watts. So what he was doing is if you restricted that 10 amps, then that 1 volt will start climbing up towards the 10 volt range and the amps will drop to 1 amp. Well, he was taking it even farther. He was taking that 10 volts by restricting the amperage down to only 1/10 of an amp or a hundredth or a thousandth of an amp. Now that voltage has a potential of 1,000 volts at 1/1000th of an amp, 0.001 amps. It's still 10 watts of power. So it's not considered a perpetual motion machine. He's using the exact same power. He's just reversing the process. He's using voltage over amperage. So the demonstration cell was nothing more than a demonstration that by restricting amps, the voltage will naturally climb. And that's exactly what that cell does. So then he went from there and he just kept trying to restrict and restrict more and more amperage down to the point where you were literally using no amperage at all, just static electricity, like walking across the carpet in the winter and touching something metal, you get that electrostatic shock. That's what he was after, was that high voltage, because you're talking that's thousands of volts just for that arc to go from your finger to that doorknob. That's thousands of volts, but the amps are so minuscule, it doesn't kill you. And that's the way his cell would operate. He would generate 1,000 to 10,000 volts of electricity with milliamps or microamps of current, and that's how his process was worked. So over the years, he was refining that process, restricting and restricting and restricting, which causes a higher and higher voltage. And then that's where you differentiate the difference between his amp restricting circuits from his high voltage resonance circuits. And the high voltage resonance is where he is now applying a pulse to you have to apply pulsing voltage to the cell. Otherwise you create this dead short. And by the pulsing circuits he designed, it would allow the amps to restrict and the voltage to climb, and that's where he invented the voltage intensifier circuit, the VIC coils, and then that was the idea. But it was all in an effort to restrict the amperage, because all he wanted was voltage. He wanted the voltage to perform the work of separating the water molecules over amperage, as in Faraday's law. So it was it was a complete opposite of Faraday's, and it's a cold process. If you let the standard Faraday's law happen, anything over 1.5 volts, any voltage higher than that in a Faraday's cell uh, starts putting in, say you go to 10, 12 volts of a car battery, that voltage now starts working on the water, and all it does is it generates heat, and it's lost, that voltage is lost to heat loss. So the cell will actually overheat and start creating steam, and once you start creating steam, it defeats the purpose of the whole unit. So by restricting the amps and letting the voltage work, it's a cold process. The cell never gets warm, never gets hot, and it never goes into exothermal runaway. So it was a really, really interesting system, and that's where I was going with my experiments. Initially was the amp restricting circuit that I made, and went to a conference down in Grove City and showed them. I made a not exact replica, but a similar replica of just a single tube cell, using that and showing the signals on the oscilloscope. And then most of those videos on my site are of
So
the
how many
high
years were you
voltage
doing
type.
it for then? How many years were you doing these experiments?
Let's see, I started at around 2008. When I first moved into the house, I started, I mean, it took a good year just to understand what it was that Stan was doing. I had no idea when the first time I read his patents and what he called the tech brief, water fuel cell technical brief. I mean, it was complete Greek to me. I had no idea what he was even talking about. Only until just reading and researching on the internet when it was still kind of young, I had to learn all kinds of electronics stuff, information on capacitors and diodes and resistors and all kinds of microprocessor chips, and to understand what it was he was doing. But in the end, that's basically all he was doing, was trying to use an electronic circuit to generate a high frequency set of pulses that would um, restrict current and allow voltage to accelerate in water. And the hardest thing of this process is getting that high voltage across the water that performs the work. And that's what my experiments are with all the oscilloscopes. There was me winding coils of wire up on a big piece of ferrite core material to make a transformer, and then adjusting a variable pulse frequency generator essentially to pulse the coil and hook it to the water, and then start building voltage across the water. And most of the time you can do this with a 12-volt battery across the water. You can stick your finger in the cell and it won't do nothing, it doesn't hurt you. But once you start getting this circuit working and start creating voltages of in excess of 800 volts, one day I keep touching the water, and because the water, the voltage you generate is nothing more than static electricity. It's a very, very high voltage, no current, just static. So anytime I touched the water, you'd see the signal on the oscilloscope drop to zero. It just dead short out the cell. So any voltage I had on there would kill it, but there was no amperage to it, so it wouldn't shock you, and the voltage wasn't high enough to give you an electrical shock. And then one day I lined up bigger coils and I put them on there, and I tune into the resonant frequency of this coil arrangement. It's called an LCR circuit. You have an inductor, which is the L. The C is a capacitor, capacitance, and the R is resistance, which is the resistance of the electricity flowing through the windings of the wire and through the water itself. So it's an LRC circuit, and a capacitor, a resistor, and a inductor, which is nothing more than a coil of wire. When you get all three of those in a closed circuit in a series, and you adjust the pulse's frequency that's hitting it, you're basically turning the thing on and off like a light switch at a given frequency. And as you speed up that frequency or slow it down, what happens is the power will first go in and charge the windings of the wire. And then once those windings get to the peak voltage that's being applied, it discharges into the capacitor. And the capacitor will charge. It's nothing more than like a little battery. It'll charge instantly, and then it will discharge back into the coil. And you get this back and forth charge discharge effect going on. And if you do it, and if you turn the light switch on and off, pulse it at the right frequency, you can tune it to be exactly in sync with those two components. And that's what is considered resonance of an LRC circuit. You go into a resonant state. And then when that happens, when you hit resonance where they're both charging, discharging back and forth at the same time, you're pulsing the circuit, you hit this point where the voltage starts taking off and it starts climbing. Even though you're putting 10 volts into it, you can see the voltage climb to 1,000 volts or more. That's how this system works. And then at that point, I was seeing on my oscilloscope, I was getting up to over 800 volts, and I just naturally reach over and touch the water to see it kill the signal on the screen. And the one day, it was making a little bit of gas. It was putting off little bubbles, and I was using distilled water, which is non-conductive. So electrolysis does not work in distilled water, but yet it was making bubbles, right? Very little, but it was working. It was doing what Stan said it would do. You could make hydrogen with this voltage. So I reach in there and I tap the water, and I just get this loud crack and smack, I got electrocuted. And the gases that were coming off the water ignited and just made this pop sound, like a firecracker. But it was real sharp crack sound, and just lit me right up. Shocked the heck out of me. So I was on the right track, and then that's basically where I was going. Was everyone's trying to find this, how this thing works, and I got to the point where the cores that I'm using to make the VIC circuit, the transformers, you really need to understand transformer technology. But I'm winding these big coils of wires, and it got to the point where I couldn't put any more wire on there. You can always go with a smaller wire, but you get so small, like the strands of hair, that it's very tender stuff. But I was able to make a lot of voltage, and I was just at the point of starting to produce gases when I finally kind of shelved the project and went back to my airplane. Because again, this was like my cars. It got in the way of my flying. And I finally decided, no, I got to put all these toys away and just finish this airplane.
And how much more have you got to do on the plane? Because I remember you saying
I'm expecting to have most of it finished this summer.
But you can't do it all year round, can you? You can't do it maybe in the winter
No,
months or something.
yeah, I'm in the winter months here. Right now, we don't have any snow. It's melted, and it was a nice, beautiful sunny day today. Clear skies too, but it was still only like 40 degrees Fahrenheit here. The problem is this is an epoxy fiberglass covered aircraft, and it requires temperatures above 70 degrees Fahrenheit to do any glue. It's basically epoxy glue that you would buy at the store for gluing things together, but on a large scale. So you need, hours, 10, 12 hours of 70 plus degrees to work with epoxy. The building I have is an all metal building, no insulation. So in the wintertime when it's snowing, I can't do anything like that out there. And that's where I'm at. All the work I need to do right now to finish it up is epoxy work. So maybe, let's see, March, it'll probably be April or May before I can physically start doing the epoxy work. But there's a few things that I can do now that the weather is finally changing here, that I can get back out there. It's warm enough temperatures to work on other small details until I can get back to the epoxy. But I'm expecting to get, what I need to do right now is finish the fabric work is pretty much all done on the plane. I just have to mix up this like a putty mix, Bondo, and cover the whole plane with that and sand it out smooth, and then it'll be ready for paint. Then it's just a matter of putting the engine back on, getting the instruments installed, which are straightforward things. And then after it's painted and done, then I call the FAA up. They set up a date, they come out, inspect the airplane, look it over, and then they'll issue me an airworthiness certificate to where I can take it out and start flying. And then after that point, they give you a restricted area of like a 50-mile radius from a base of operation. And you tell them where you want to fly out of, and they keep you in this like 50-mile radius for 40 hours of flight time. And it's nothing more than a time frame to allow you to test the aircraft to make sure it's safe for travel outside of that area. So the sooner you can fly off the 40 hours, as soon as you get 40 hours, you don't even have to contact them. You're done. I can go anywhere in the United States, North America I want, as long as I have the correct
And
equipment,
how's this
radio
plane
equipment to
running?
go in.
How's this plane
Pardon?
running? How's this
How's it
plane
running?
running? Yeah.
How's it running?
What's it running
Engine
on?
wise, or oh, it's a gasoline. Yeah,
Right.
gas, regular. I'll be running automotive gas. I don't need to use aircraft gas because it's an actual car engine. It's out of a Subaru Legacy. It's a 2.2 liter engine from a Subaru Legacy. It's a car engine that was converted for aircraft use. That's the
Right.
nice thing about experimental. That's what's nice about experimental aircraft. You can use any kind of engine power plant you want. But those Subaru engines, they were originally designed for aircraft use when they first made them. They're a flat four boxer engine, as they call them over there in Europe, boxers. So it's just like an aircraft engine. All piston-driven aircraft engines are just flat 4 cylinders or 6 cylinders. Great big cubic inch motors, though. You know, they go up to 500 cubic inches. This is a 2.2 liters, which is maybe 130 some cubic inches. And some aircraft engines are, 500, 520, 560 cubic inches. They're big motors. But this one's about 140 horsepower, and the airplane will cruise about 150 miles per hour.
Yeah. There was a question in the chat room. It was more to do maybe because you said that you were in the Air Force, wasn't it? No, Navy.
Marine Corps.
Yeah, Marine Corps. Because you were doing with planes, and it was Marilyn. She just wanted to know, like, did you spray anything, or did you know about the spraying? You know, like the chemtrail stuff, because they've been spraying us for years, haven't they?
Yeah. Well, I was in the service in the mid 80s, from 1982 to 1986, well before people were probably into the chemtrail stuff. So I didn't. The squadron I was in was a refueling squadron. They would do in-flight refueling and cargo carrying. That's the only thing we did. I never seen anything like that. I've never even heard of chemtrails until, a few years ago. But
Yeah.
but if you yeah, so that I had no idea. I was only 18 when I went in, 22 when I came out. So I was only limited to the airplanes I worked on. I didn't have access to any other aircraft. There was all kinds of different squadrons I was located at Cherry Point, North Carolina, and I also served a year at Okinawa, Japan. And I was on an airfield with helicopters in Japan. But here in the United States, it was they had the Harrier jump jets. We had EA-6B intruders, the F-4 Phantoms when they were still in service then, but they were all different squadrons, and we couldn't go from squadron to squadron. But we were the biggest planes on the airfield, and we didn't do anything like that at all. I think that's well before they might have started spraying. I don't know how far back people claim that the spraying happened, but I didn't see anything like that in my business. And then I don't think the Marine Corps would be into that. I'd expect the Air Force is probably more along that line. I was in what was called the Air Wing, the Marine Corps area.
They didn't mind poisoning us.
Yeah, I believe they are. I actually got a video on my channel there of starting and stopping chemtrail. It's one little short video I took with my cell phone at work one day. I just go outside and looked up. So, well, looky there. I'd seen one on the internet, and I was like, wow. And then I look up, and then there's one there in the sky, and it's a real short video right there on my Dynodon channel. Happened right over Erie, Pennsylvania. Come on.
Those damn things are happening outside my house all the time.
Well, this one's looks like a dash line in the sky. You can see the contrail start and stop, start and stop.
What, you want artists to play it? Artists will play it. Artists, are you there?
Yeah, I was typing something in the live chat, so I had to take some time.
Anyway,
yeah, the video icon, you can see it's a picture of the sky, and you can see the little dash lines in the.
Yeah, chemtrail starts and stops.
Yes.
Okay.
Yeah, it's a short video. It's not very long.
Yeah, I can play it at a slow speed, maybe, if you want to.
Yeah, it's fine.
I play it a little bit slower that everybody can see it as good as possible. I want
at the very end.
Hang on.
I say, if you look carefully.
Now wait a second. I have to actually case the window and then.
Yeah, I think he's just explaining.
Okay. Sorry. Okay. Go ahead, Don.
Oh, okay. Yeah. You can see where it's a nice solid start point, and then in the clouds, there you can see them starting to start and stop. And at the very end of the video, you're able to see the last one as it's starting. You can see the shadow of it in the clouds below it, but it's only at the very tail end of it, the last few seconds. But you can see clearly how they started and stopped.
Wow.
Because it was a solid stream all the way up, and then it started doing that. Where was that, like September, October?
Wow.
This was just on my cell phone. Then just before the end, you can see the shadow in the cloud of the last one before the video stops. Because it's higher than the clouds. But I'd never seen that before in my life. There it is. You can see the shadow behind the last white bar. Yeah, you just make out the shadow on the end of the white one. You know,
That's a bust right there, isn't it?
yeah. Have you ever seen the explanation for that? They claim that there's little turbulent rolling clouds up there that are reaching up and causing air to go up in those pockets where the condensation isn't. That's how they explain that away. Yeah, that last mark, you can see it looks like it's dark gray and then it's white. That's actually the shadow in the cloud of that contrail chemtrail.
Yeah.
I wondered, because you also like your gyrocopters, don't you? I wonder if you've got a few videos on there of you in your gyrocopter, haven't you?
Yeah, those are some of my earliest YouTube videos. There's if you go all the way to the end of them, the very first few was I had a friend trying to make videos, and that was back before YouTube. You could upload any brand of video camera, and the one I had, yeah, that one there is I got the camera mounted on the strut of the gyrocopter. That was at a picnic, and that was during one of the hurricanes came up the East Coast. This was our annual picnic for our experimental aircraft chapter. And the winds that day were 20, 30, gusting 40 miles per hour when I was flying. I was the only one that flew that day. Everybody else drove in on their cars. Normally, because we have this at an airstrip like this, and people will fly in their home-built airplanes, and we just have a big picnic. But I was I trailer this thing, the blades come off, I put it on a trailer, and I pull it with my car. And then I put blades on it, and I went out flying, and the winds were, 30, 40 miles per hour that day.
Yeah,
gyrocopters love the wind.
It's very clear you aren't afraid of any heights.
No, I wouldn't.
I almost get. I'm actually afraid of heights, and even watching this video gets me a little bit.
My feet.
Wow.
Yeah, you can see there when I took off. As soon as I broke ground, the nose turns to the right because that's where the wind was coming from. It weather vaned. The winds hit me, and it just weather vaned into the wind, which you normally do anyway. Otherwise, it'll blow you off to the left side. But yeah, it was a real windy day. But yeah, I've been flying these things for over 30 years. It's a lot of fun. It's like a dirt bike in the sky. I just take it up there, throw it around, have fun for 15 minutes, and then come back and land. It's not a cross-country machine. I don't fly from airport to airport. I take it to an airport, put the blades on, fly it around a while, and then take it home.
And how are you strapped in with an? How the strap?
I have a 4-point harness. There's the lap belt you can see there, and then there's shoulder harnesses that come down over my shoulders. It's a race car harness.
Yeah.
Don, I was just going to ask, weren't you cold up there? Is it not really cold? You only got shorts on, I can see.
No, this is the middle of summertime. It's like 80 degrees here, 80 degrees Fahrenheit. So it's very warm. It's like July, August. Actually, it's August. We have the the picnic every August. So it's the hottest time of year for us here.
He's going up.
And I'm only flying a couple 100 feet at that point. Oh, you're talking about afraid of
Only.
heights. Flying, yeah, flying in airplanes and gyrocopters, it doesn't really bother me. But if I get up on a long, shaky ladder, that bothers me.
I have to say something
I can.
else. Quite flat, isn't it?
Oh yeah, yeah. I have on my other channel, my Don Gable channel. I did a video of the horizon. I was holding the camera and I did a 360-degree turn. And I'm only up like 1,000 feet is all, but I did that intentionally just to show you that the horizon is flat and it's consistent on its length. You know, if you can see out, say 5 miles, you can see 5 miles in front of you, you can see 5 miles to the side of you, you can see 5 miles behind you. It was a point I was trying to make, that no matter how high you are, you can only see to a given distance before your vanishing point, you know, kicks in. That's the vanishing point. And my point was, because you can see that, it's literally you're drawing a circle, a 360-degree circle around you. So what you're looking at is an edge of a circle. So when you get up to a height, that edge actually looks like curvature to some people, but it's not a curvature. It's just an arc of the horizon as it goes around you. And then my other video in that same channel, you can see a video with a tabletop. And what I was doing was I put the camera in the center of the table to show you how flat it is. And as you raise the camera up, the edge of the table, if you envision that as your vanishing point, it starts to look like a curve. So as you raise the camera up and down above the table, it looks like a curve.
Is that on this channel or your other channel?
It's on my Don Gable channel.
Oh,
To
I
go
can
back
go
to my
to
other
there.
channel.
Better
That last
curves
video
do not
around
perspective at altitude. That one? This one?
that one, yes.
Okay.
All my videos are short. You know, I try to keep them around 5 minutes or so because they take 3 hours to upload. These are high def videos.
I think I just show that other one so people can see it. Yeah.
Yeah.
Yeah, maybe.
So what I did there,
Yeah.
okay, yeah. So what I'm doing there is I put that paper on the back edge to kind of give you a defining line of the horizon vanishing point. That's as far as your vision could see. And in the center of the table, I have a piece of tape with so that I can set the camera right there, put the lens right in the center. So you're looking straight out at the table. And I start out with the camera sitting on the table, and you can just vaguely see a slight hump in the edge of the table. Then as I raise the camera up a little bit, then that curve starts getting more pronounced. But it's a flat table. All you're seeing is the edge of your vision is a circle. It's a 360-degree circle around you as of your point of view. So people are mistaking that vision arc as curvature, but it's not curvature. That's what that video is about. It's perspective.
Have you got it on slow, artist?
No? But it makes
Okay.
it very clear how you explained. I can skip a little bit through it. If you want to.
Yeah, once you get to the point where I set the camera down.
Yeah, this is, let's see. Here you set the camera down, I believe. These are some measurements.
Yeah, I was doing the experiment. I don't know if you guys have heard of Wolfie 6020. He's a corporate pilot and he's a ball earther. So I make these videos to show to him that you're not looking at curvature, you're looking at a vanishing point that is an arc circle.
Oh, yeah.
So I was using these numbers because he flies at 45,000 feet.
Did you make him flat?
Say again?
Did he go flat?
Yeah, did he go
no,
flat?
no. Wolfie, no. Wolfie is a dyed-in-the-wool ball earther.
You got to keep knocking on the door there, matey.
Here are you setting it, the camera?
Yeah, okay, there. Yeah, you can see it, just barely a hump.
That's actually a very clever experiment. Very clever.
And then you can see as I raise the camera up, it starts to look more like a curve.
It's cool that you have on the end of the table and a fly for the perspective. Over here, there's a fly
Right.
sitting there. See? That's cool.
You know the table's flat, but it's curved. I got that piece of paper there to represent the skyline, and then the table is the ground horizon line in the middle. And as you go up, that line, even though it's a flat table, it starts looking like a curve because that's the limit of your vision.
Yep.
When all the atmosphere collects, kind of thing. Probably range your vision.
So after I made that video, then that's when the airplane video on that same channel is where you see I was up there, just did a 360-degree turn, so you can see the horizon always maintains its distance. It never changes.
I can show that video over here.
Yeah, that one there. It's just a short video.
Yeah. So
Just
people
showing
can
a
see.
turn. That's Great Lake Erie right there. One of the Great Lakes, Erie. This was towards sunset too. I'm just trying to show that as you do a 360-degree, the horizon doesn't get any farther away. It stays the same. So essentially you're seeing in a circle.
Yeah.
And the higher you go, that circle starts looking like an arc or like a curvature, but it's not curvature, it's just a circle. You're looking at a flat circle because your vision can't see past the horizon.
Yeah, you must laugh a lot when the ISS is going over the ball Earth then.
I
when
actually
the
got a
show is-
P900, and I've been waiting for a lunar pass of the ISS so I can go out and try and get pictures of it.
Oh wow! Yeah.
I've seen other people get them.
I've been following this guy, propaganda something media he's called, and he's reckoning that Google will say things are so far away, but his P900 says it's half the distance. So the planes, the chemtrails aren't great big planes far away, they're little planes not so high, so they look further away and bigger because you're always being told about distance and height and speed, and the planes aren't going as fast as they are, and they're not going as high as they say they are. This is what he's reckoning because his P900 tells him.
Yeah, I
thought
think
that was
that's probably the same video I saw that you're talking about. He was trying to make a point that looking at an airplane with the P900 at a distance, a horizontal point away from, say, I don't know, 3 miles or whatever, 10 miles away, he can zoom in onto it only so far. But then a plane that's overhead that's supposed to be farther away, higher up, he's able to get a bigger picture of the plane in the zoom, which what he's saying is they're lying to us about the heights that these planes are flying at, which really wouldn't be hard. If they're giving us the information saying that for every 1,000 feet we go up, the barometric pressure changes this much, they can make the instruments to that point that when they're saying you're 10 miles up, you may only be 5 miles up. You know, they can fudge those numbers. But yeah, he was the one I just watched.
Oh, so did you see the one where when the plane's landing, and for half of it, a truck is going faster than the plane landing? So these things are going really fast when they're landing. But when I last took off, I asked someone, because now I would ask different questions. So I said, "How fast is it when a plane takes off?" And they said about 80 to 100 miles an hour. And I thought, oh. I was thinking 200 miles an hour. I don't know what, because when they whack those engines down, you feel like it's a rocket, we're taking off.
Yeah,
And
that's the G-force of acceleration that you're feeling there. But yeah, most airplanes, you're talking commercial airliners, yeah, they probably have to be over 100 miles per hour. But yeah, 80 mile an hour would be kind of slow. I'd say at least 100 plus, depending on the bigger the plane, the more speed it's
on a
going to take.
propeller plane. It did have jet engines, but that was on that one. Yeah, so it was quite a small.
Well, I saw a video where I can't remember who it was. It was a brand new video, but the guy was using his P900 to show a zoom on an airplane that's off in the horizon after it's taking off, showing that, I can only zoom in this far. And they're kind of grainy, fuzzy looking. And then when he points it up in the air at an airplane, it's at 35,000 feet. he's able to zoom in on it at a bigger range. The airplane is filling the camera larger than it would if it was the same distance away on the horizon, just taken off. So he's trying to say that the planes aren't as high as they say they are, because the camera zooming in on a plane at 10 miles in the air should be a lot smaller than the plane 10 miles away taken off at an airport at ground level, was the point he was making with that latest video I saw. So it's probably a different video than the one you're talking about.
No, it's the same one.
Oh, is it the same guy? Okay.
Same
Because it was
guy.
just something new that popped up. Yeah.
He's also done one about distances, because again, the same thing. So not just up, but what he's looking at on his P900 in front of him. But it also then tells you that anybody that catches the ISS the size of an aeroplane in their viewfinder, then the thing is only a few miles away.
Oh,
Whatever
yeah,
they're
it
capturing
could be.
is only a few miles away. That's what he was telling you.
Yeah, I've been watching the ISS tracker. There was actually one that was supposed to transit the moon. I think I missed it, but our weather's been overcast here for so long I wouldn't have been able to catch it. But I keep watching it, looking for a nighttime passing over the moon to see if I can get pictures of it with my P900 in video mode. I just put it up so many minutes before and after it's expected to go through. I want to see if I can get what these other people are actually showing on their YouTube channels when it goes by. You know, it only lasts for 1 to 2 seconds. I want to see if I can do that.
Also, he's got one on there that he can actually zoom. He can't zoom into this sign 1,000 meters away, but he can zoom into the sun closer. So he's basically saying the sun's a mile or two away from you. You can zoom right into the sun. He can't zoom right into this on the setting he has on his camera, so he can't zoom right into the sign. And he's like, he's changed my mind on photography now, because that's all a lie as well. And don't forget,
Oh yeah,
those
yeah,
P900s make star trails, which are a load of rubbish.
yeah. I
like,
was
someone I know put 2 photographs in, and it did the whole star trail. How could it do a whole star trail on 2 photographs? But anyway, that means that part's fake.
well, the P900, the setting for star trails, if you're doing the time lapse, it tells you right in the manual that it will leave the star trails, because it's kind of like taking a picture on top of a picture on top of a picture. It just keeps adding all the points, and it doesn't delete the points prior to it. So when it takes a picture at the moon at this point, and then the next picture it takes, it's a little more, but it doesn't eliminate the previous. It's like they're just taking pictures one on top of the other. So they're all making, that's how it's generating a star trail. That's for time lapse. They tell you right in the manual that a time lapse will create star trails. And that's the only way it could do it, because every time you take a picture, it should just show the thing progressing, moving. It shouldn't make a trail. But because it has to be just taking, it's like a double exposure. You take a picture, but you don't advance the film to the next one. You take a second picture, you get 2 images on one picture. Well, that way you'll get every single position of the moon and stars will stay in the image. They won't be erased for the next picture. That's the
And there
only
was
thing
another
I could figure.
I mentioned him as well, as that he'd also understood this 360-degree circle of light sight, you see?
Yes.
Like you were talking about.
Right. The only way to do a star trail to see a full complete circle, I don't know how you could do that, because you don't have 24-hour darkness unless you're at either the North Pole or the South Pole. In order to see a complete circle of star trails, that's not possible. Only, like right now, if we're coming up on the equinox already, so we're kind of at a 50-50 mix. But when you're at dead summer, dead winter, North-South Pole, if it's true, you should be able to do that 24-hour darkness and 24-hour sunlight and do a star trail that way. But from anywhere else down here where most of us live on the ball, we wouldn't be able to only see 6 or 8 hours of star trails before sunlight.
Yeah, I agree with you. I just wanted to say that Z Proxy, he's in the chat room. Him and Stan Smith, they do a lot of work with 360 cameras. And he wanted me to ask you, have you used a 360 camera yet?
No, I contacted him and asked him if he needed some help, and he did reply. But I've been laid off from work. I'm actually going back to work next Monday, so our winter lull is finally done. But I want to buy a 360 camera and take some stuff for him and send to him so he can see it at my latitude. I'm basically 42 north on the latitude up here, so it might help his research out. But I haven't picked up a camera yet. I just don't have the extra funds right now.
If I give Z Proxy my email, you've got his email address then, or should I get his email address? He can email me, and
I've already got his. I think I have. Yeah, I've got his email address already, or not Zpoxy's, but I have Stan Smith's.
There you go, then, Z Proxy. See, you need to write to Don because he's asking in the chat room. Because obviously they're doing experiments, and we had Stan on. Was it last week he came on, or the week before he came on, and he showed us more about his 360, and they so want to get more people to do 360.
Yeah, I was looking them up on eBay, and like the one he used, it's like 60 some bucks here on eBay, but I just haven't had any extra money to buy one. Then I'm gonna have to find a way to put it outside somewhere and mount it. And I do have some old PCs that I can hook up and just put the thing on, 24/7 if I can figure out how to do all that.
Excuse me, I think I'm going to sneeze. I've just got to turn my microphone off a moment. Sorry, I was going to sneeze then. I think I've caught another cold today. It was freezing earlier on, and then I just seemed to be a bit more cold-like. But anyway, yeah, so there you go then, Z Proxy. So Stan needs to write to Don.
What kind of latitude are you guys at over there where Stan's taking the videos? What north
my
heading?
goodness, I have to look it up on my phone. Hang on a second, but I can't remember. I used to know it, didn't I? But now I haven't looked at pictures for a while. I can't think. Let me just go to a compass reading. I've got some on my phone.
Because mine's almost exactly 42 by 80. But I'm at 42 north.
I've just got to find. Gone too far, haven't I? I should know it, really, shouldn't I? Germany's not far.
51 or some 51, 52, I think, Karen.
Yeah, something like that. Yeah. Just still trying to find one. I've gone back too far, haven't I?
Are you close to Aylesbury?
Yeah, not well, an hour.
North or south?
East.
What's the town called?
Newbury.
Newbury.
I'm just trying to find my. Oh, here we go. It's not on there, is it? That's when it was new.
All right, there you are. You are 51.5 degrees approximately.
Thanks, Astral.
So that puts you guys higher than me then. Closer to the North Pole.
Unfortunately, yeah, we're feeling it today. Well, me and artists went to Greenland, and they were in shorts and t-shirts. On the pictures on Google Maps, they were all wearing like shorts and t-shirts, and we were like, wow. And they get up to 20 degrees in the summer, and I was thinking, we struggle to get to 20 degrees anymore. It's like, well, we're having the same temperature as Greenland.
Yeah, that's one of those things where when you're living in the cold weather.
Yeah, hang on, Don. You've gone really quiet now. I said, speak now.
Who you want to speak?
Oh yeah, I think your talking piece is too high up. On your headphones. If you're talking through there, it's too high up.
No, I think he's just talking into his phone. He's just plugged his microphone in.
Yeah, my phone doesn't have.
Oh, that's better.
Muffled?
That's it.
Right. Could
that's
be
better.
my. All right. It just might be the headphone jack. Yeah, it might be the headphone jack is all.
Or
Yeah.
you put your fingers over it.
Because it doesn't have a
Yeah.
it doesn't have the microphone plug, just headset. So I'm using the actual mic from the phone.
Okay.
Cool. So, is there any of the other experiments while we're here you'd like that artist to show? You can talk us through any of the Stan Mars or any more of you flying?
Let me think. What do I got? Well,
'Cause
the only
obviously
flying
people-
ones I got are basically the gyros on my Dynodon channel at the very bottom. And there's if you want to see a kind of a neat thing that we do, we have a gyrocopter. It's called a gyro glider, and it's hooked to a cable. And we use a pickup truck. We hook it to a 75-foot cable on the back of a truck, and we pull it up and down the runway like a kite. And that's what we use for entry-level training for gyrocopters. It allows you to get on a machine. The machine has no engine on it. We just pull it. And because it's an auto gyro, as we go forward, the rotors will spin up and it'll take off and lift up, and we can move left and right with it, just like you're flying in the air. We just can't, make circles and stuff.
Yeah. Is it
It'd
that
be way down on the bottom of
project update?
way down on the bottom of the list. It'll be some of the very first videos. You got to go all the way to the end. There you go.
Gyrocopter flight video, testing new software.
The very last two.
Gyroglider test. The
Yeah,
last
the
one.
very last two. Yeah.
Okay, I will play them, both of them, because they're not that long.
Yeah, so I got a guy sitting in the back of the truck taking this video. It's basically just like flying a kite. But once you get in the air, it flies just like a normal gyrocopter. It's just that I can't go anywhere because I'm tethered to the truck. But I can go left and right, up and down. It's full control. And what this does is it allows us to start training somebody who's never flown a gyrocopter before. And it'll teach you how to get the rotor started, get them up to speed, the correct way to take off and correct way to land. And the truck controls our speed. He speeds up and slows down as needed to make the thing fly. But it can carry a passenger, and that's what we use this for, is for training. There you can see it's broken ground. This was just a shakedown pass. I always put the blades together. We do a quick test run, make sure it's not going to have any shimmies from the out of balance blade or something. And then we'll go back, and then we'll start putting people on and doing the training sessions. But there's no
So this is
engine
how-
on the machine. It's
This is
just
how you learnt in one then. This is how you learnt to
That's-
fly.
Yep, that's where I started, right there in that exact machine. That machine's, probably 40 years old, 50 years old. That's how our club starts training. Then you advance into a two-place powered machine for further training. But this will get your reflexes used to controlling the stick for left, right, up, and down. And once you learn, you get enough time on this thing, it becomes second nature, like driving a car with a steering wheel. And then when you add an engine to it, now you got to work one hand with a throttle, like on a motorcycle, to speed up, slow down. And you got your feet there that works the rudder pedal to keep you going straight, left and right. Whereas with this, the cable that's hooked to it pretty much dictates what direction you go on. But on a powered machine, when you add power with the propeller, torque always acts in the opposite direction. So it tries to steer you off the runway, and you have to use your feet to steer when you're on the ground. Then once you get in the air, then you steer with the combination of your feet and the joystick.
What about that one then, artist? Do you think you could do that one?
This is real easy. It's a lot of fun.
It's already
For
playing
somebody-
the second video, Karen.
Yeah, it's the same
No.
thing. You see how far I'm whipping
I
that
didn't
over
say
from
that. I
side?
said, do you think you could do that one, artist? Do you think you could go up in that?
No.
No, I couldn't. It
I
looks
took
so
the-
easy, but I wouldn't like it.
I'm afraid of height, and I've been since a child. When even my dad carried me down from a staircase, I was already shaking because I was afraid of heights. So it's very
Yeah, well, these things here, yeah, people get really uneasy because there's nothing surrounding you. When you look over your leg there and look down, everything's around you. You're in a wide open. It's pretty intimidating at first. Now my wife, I took my wife up on this, and she was uneasy, but I took it real easy. I didn't do any moves, just took it up in the air and then straight ahead and landed. But in the airplane, I take her flying with me all the time, and she is definitely afraid of heights. She got up on the roof here when we had to re-roof the house a couple years back, and it's only like 10 feet up, and she was worthless. She couldn't do anything. She was so scared to death. But I take her flying all the time, and it doesn't bother her sitting inside an airplane. She's perfectly
No,
fine.
airplane doesn't bother me. I also went in an airplane because at a certain height, you don't see that you are being high anymore. It's like looking at a TV screen. So actually,
Yeah, he's just looking at a picture.
yeah, you're looking at the picture, not anymore. You feel that you're high up anymore. So in a plane, I don't.
My first flat Earth video is that one in the upper left-hand corner with that little sandblasting cabinet, that red box. That was my first flat Earth video.
I can play it for you if you want to.
Yeah, it's all right. Like I say, none of my videos are real long, but that was my first one that I had questions about. I hooked up a shop vacuum cleaner to my sandblasting cabinet to apply vacuum to it. You do that when you're sandblasting, so it sucks out the dust as you're blasting rust and stuff, paint. So it gets dusty in there, so use a vacuum cleaner to suck it out. And when you do that, when you turn the vacuum cleaner on, those gloves are sealed, and when you put your hands in, so you got inside, you generate a vacuum, the outside is atmospheric pressure, so the gloves will sit there and pop straight out, solid, stiff. And I was trying to make a point that an astronaut's suit in space would do the same thing because you have a differential pressure going. You've got the zero vacuum of space against a 1/3 pressure inside a spacesuit. So atmospheric pressure, if you use PSI-A, which is pounds per square inch absolute, space is 0. And what we breathe here standing on Earth is 14.7 PSI-A absolute pressure. So the difference of a vacuum in space and a spacesuit, the spacesuit is only pressurized to 1/3 of atmospheric pressure. So they're only pressurizing it to, say, 5 psi, but it's still a differential pressure. It's a differential pressure of 5 psi from absolute. But either way, 1 psi differential in there will still do the same thing. And that's where they say these gloves will get so stiff there. And I'm only pulling a differential pressure of like 2 or 3, not even getting close to the 5 that an astronaut suit would be at, which means the suit would be even tighter than this experiment. But as soon as you turn on the vacuum, I have a gauge there that reads vacuum, so you can see how much vacuum is being pulled in the gauge inside the cabinet, and it's nowhere near what would happen in space.
Sorry, Don. Up in space, well, here on Earth as well, they measure it in torr, don't they? And the torr, that it's absolutely incredible. I mean, yeah, like you say, it's immense vacuum.
Yeah, correct. Yeah, torr is a measure of vacuum itself, but if you look at it in PSI absolute pressures, space would be 0, and torr would be, it's really, really low 0 with many numbers past it. But but it's, for the sake of this argument, it's just space is 0. Where we live is about 15 PSI, but we don't see it as 15. We see it as, like, if you had a car with a turbocharger on it and it's got a little boost pressure gauge on it that can read vacuum on one side and boost on the other side, the gauge, the 0 will be in the middle. So when the engine's under a normal load, it's pulling vacuum to the left. And then when you step on the throttle and the turbocharger kicks in, the boost pressure goes to the right. So on a gauge like that, vacuum would go from 0 to 30 psi negative. And then under boost, you might go from 0 to 10 or 15 positive pressure. But that's all reference to our atmospheric pressure at 14.7 to 1. And space would be right down by 0 on a gauge like that. But it all boils down to differential pressures. Spacesuits aren't pressurized to what we experience in life at 14.7. They only pressurize it to basically 5 psi, and it's supposed to be pure oxygen, because if they don't run pure oxygen, they would suffer from hypoxia from high altitude. If that makes any sense.
Can you just explain what's happening into the gloves and that then?
Yeah, it's just showing, because the inside of the gloves are on the outside, you know, it's, you put your hands into the gloves from the outside. When I apply a vacuum to it, the pressure that's we're standing in is forced, it's inside the gloves. So then the chamber is now being hit with a vacuum cleaner, and it's creating a vacuum. So it's making the gloves expand out real super tight, and it makes them really hard to bend and handle and close your hands and make a fist, because the pressure differential is wanting that glove to spring out to its form that it was made in. So a spacesuit, if you have any airspace in your spacesuit, which they do have layers that constrict and hold it to a certain size, but even any little bit of air in there, when exposed to a vacuum, is going to blow up like a Michelin tire man, you know, or a Stay Puft Marshmallow guy from Globebusters, you know, from not Globebusters, Ghostbusters. You're going to blow up like a big balloon.
You know that test they did in the 60s? They actually say to that guy,
Yeah,
we'll see how long So they knew it wasn't going to work. See how long you can stand it in there. That's what he said, stand it. So
yeah, and they said he had a small leak in the suit, you know, but he didn't last long. They didn't even get nowhere near the pressure of this vacuum that I'm showing with this test here before he passed out. That vacuum in that experiment was probably less than what you've seen in this little sandblasting cabinet before he passed out. But yeah, you can see there how stiff the glove becomes. They're standing by themselves, you know, you don't even have to put your hands in them. They just stand straight out full, like you filled them full of cement.
So no space astronaut then.
Yeah. That was the problem I have. But then the guides with this video, if you go down through the comments, people had sent me a link to a book on how these suits are made. And I'm looking through it's a PDF file, and I'm going through it to see how they design these space suits so they withstand that type of environment. I'm looking at it and thinking, you know, all this stuff they're saying, they got all these sketches and drawings of all the layers of fabrics and materials. There's a rubber bladder in there. There wasn't one picture of a real spacesuit in there. It was just all drawings. It was like, I found that pretty odd. And that's where the guys are telling me, yeah, but these things are only pressurized to 1/3 atmospheric pressure, and they use 100%
And they said in that
oxygen.
video, the one in the 60s, that they were actually making it, the condition inside, exactly the same as the moon, but none of them were floating around. He wasn't floating around in there, was he? He was just standing still.
Yeah, well, the moon don't have any atmosphere, so it's 0 atmosphere, just like space. But the gravity, the only difference is gravity is supposed to be what, 1/6 or something.
But they said that they had made it exactly the same as the moon in the container. But anyway, Don, thank you for explaining that, because none of us believe in space anyway, but it's just, even you can work that out. So why, I just wish that NASA would be closed down personally. But is there any other experiments, as Artis is there and you're our guest, to like get him to show?
All right, yeah, I just have to see if Artis will
put maybe the airplane you are building, or
I mean, if anyone's interested in it, I'll be more than happy to explain anything.
Oh yeah, for sure.
The upper right hand, the upper right hand video, you see the airplane? That's a picture of a real one right there, and that's what mine is a replica of, the real thing. They actually used those in England in World War II.
Oh.
But that's kind of where my airplane, well, it's a little farther along than that, but I have the plane upside down to finish the fiberglass work. You can't very well lay fiberglass when it's sitting the other way. But this is an airplane that's it's what you call a plans built, home built experimental airplane, meaning I bought a set of blueprints and you had to cut and make every single piece of the airplane from scratch from raw materials. All that landing gear, metal stuff you see there, I made all that from scratch, just plain tubing. It's all chromoly aircraft tubing. The fuselage, if you see in some of the real early videos, it looked like a box, like a boat, a wooden structure. But it's little, real small strips of like 3/4 by 3/4 inch, which would be like 20 millimeter square spruce sticks, and they're all glued together in a lattice, what do you call it? Kind of like a bridge, a truss assembly, and then it's skinned with a little bit of real thin plywood, and then that's the basic structure of the plane. The spars are all wood laminations of strips of wood glued together to make the strength of the spar. But that's the whole strength of the aircraft. The structure is in the wooden box, and then you cover all that because the box is square. The airplane has to look like this, nice and round and contoured and shaped. Then you start covering it up with styrofoam, stuff that you'd buy down at your local hardware, your home supplies for insulating your houses. That's what that blue and pink foam is. Just bought it at the local Lowe's, Home Depots here in America. And then you put the foam on, glue it in there. It's non-structural. It's just for shaping and contouring to give you the nice, smooth, round shape of the plane. It gives you the covering. And then that whole thing is covered with 2 layers of fiberglass cloth with epoxy resin, just like any fiberglass thing you might have. Any kind of car that's built with fiberglass, like the old Corvettes and Ferraris and Lamborghinis were built in fiberglass. Same procedure, except for these are what you call hand layups. You basically make a shape and then you cover it in fiberglass, and then that's a part of the structure itself. But that's pretty much all it is. It's like a great big radio controlled model airplane, half scale. It's half the size of the real one. But everything on this airplane was built.
Is it 2-seater or a 1-seater?
This is a single seater. Yeah, even the real ones were only a single place. They didn't have any 2-seat trainers for the Corsairs. The real ones are really big. They're 40-foot wingspan, which should be 12 meters, 13 meters or something like that, maybe. So it's a big plane, big, heavy airplane. 2,000 horsepower radial engines. And this is half the size, but it's all wood, foam, and fiberglass. It only weighs, come in maybe about 700 pounds with engine, everything on it. But the landing gear completely retracts up into the bottom of the wing. There'll be some doors that close behind it. You can't see it, so it streamlines the plane, makes it faster. But this airplane will take, you're talking about takeoff landing speeds. It'll take off probably in the 60 to 70 miles per hour range, and it'll land somewhere around that 70 miles per hour speed as well for landing. So it's faster than you would normally drive in a car. And that's pretty typical of any airplane.
I have a question for you. When you've built it, obviously it has to be tested by someone or checked out? Do the FAA have to check it out for you, or how does that work?
Okay, once I'm finished building the airplane and it's ready to fly, I contact the FAA, and then the FAA will arrange a meeting to come down and look the airplane over. They have these certified inspectors, so to speak, like taking your car for an inspection. They will come out, look the plane over, and they're generally looking to see that it's built nice and sound and it's not going to fall apart when it gets in the air. And then they will issue me a certificate, an airworthiness certificate, saying, okay, they deem that this aircraft looks suitable for flight and that you are now legally allowed to fly it. as long as you have the pilot license required for the aircraft. But yeah, they come out and inspect it, say, okay, you look like you did a good job. It looks sound. You followed the plans. Okay, here's your certificate. Now you can fly it, but you got a 40-hour minimum 40-hour flight testing time that you have to do in a given space, that you can't go out of this zone for 40 hours. But I will be the test pilot.
Right. Okay. So that's to prove its airworthiness.
Yes, that'll. Then after the 40 hours and everything's fine, you can have problems that you fix here and there, but it's a test. It's a test phase for the airplane and for you before you start taking it out into other areas of the world, so to speak.
Right. Okay. But they're not going to be standing there watching you out there to see that it's flying okay, or do they just have to take your word for it that it's fine? Well, obviously you're not going to get in a plane that's going to fall out of the sky, are you? I hope not. Anyway.
Yeah. Yeah, well, these planes were designed back in the mid 70s by a company called War Aircraft Replicas, and it's changed hands through the years, but it's originally started out in California. But yeah, once the FAA looks at, inspects it, and gives you a certificate, they say you want to go kill yourself, go kill yourself. They don't care. They just have to come in after the accident. So if you have an accident with it and it's reported, then the FAA will come out and they'll have to investigate the accident, whether if you're hurt, injured, or killed. It'll be a registered aircraft, and they have to look at it just as if Boeing built a plane. They have to determine the cause of accident. But yeah, once they look at it, they're done. Their hands are clean. They don't care what happens. They don't want you killing anybody. They don't want killing yourself, but it's in your hands.
Okay. What about like registration? You have to have a tail number on it, don't you?
Yeah, you do that before it even gets inspected. I can get a registration number for it right now if I want.
Okay.
That's easy to get.
Is it expensive?
Most of that stuff was free. They just recently, in the last few years, started because there were so many airplanes out there that were registered, and they had no idea what planes were flying anymore because they don't keep track of it. So what they decided to do is making you re-register your aircraft every 3 years, so they know that it's still actively flying. But it's only a $5 fee.
That's cool, man. I think
Yeah,
if it
every
was
3 years.
I think if it was over here, like I'm in Denmark, it's expensive anyway to start with. If you just want to make a kit car, I don't even think you're allowed to make a kit car. I don't think you are actually. So you can forget about making your own plane.
Well, you'd be surprised. I mean, home-built aircrafts, Europe is really big on home-builts right now, but they're into what we call over here light sport aircraft. It really started over there in Europe. Your flying laws over there, it's not the FAA. I can't remember what you guys call it over there, but they they have more lenient weights and stuff for aircraft. You can build ultralights over there with a higher weight than aircraft over here in the United States. An ultralight over here is nothing more than a pair of wings that you'd strap on your back. I mean, that's about it. But over there, you guys have a much higher gross weight that's allowable for ultralights. But over there, your companies, other than being someone like Boeing or Cessna or Bonanza, they have a lot of small home-built airplanes being built in the factory, and they can turn around and sell them to the public as a turnkey airplane. They don't have to be a kit. You can buy them. Well, over here in the States, they came up with the light sport aircraft category that allows us, people that want to fly an experimental but we don't want to build it, gives us the option to buy that airplane and fly it just like it was a Cessna, but it's still registered as a light sport aircraft, which is kind of an experimental category because it's not a certified airplane like a Boeing or a Cessna or an Airbus. So you guys started that movement, and they've finally come here to the States. It's been a few years now. It's probably been 15 years plus since we started that. But it's made aircraft available over here that you don't have to build yourself. But the plane has to be built to a specific model. Everything's got to be exactly the same from plane to plane to plane, other than radio equipment now. But they can't vary from a specific model as they build the plane. If they want to build a variation of that model, then it has to be recertified. But it was meant to be a lower cost aircraft for the average person to buy, but the average person can't afford $100,000 plane because that's what all these planes cost. They're all over $100,000 now. I can't afford that. My house is $100,000.
What are we looking at now?
That's just the cowling, because the airplane's built separate. This is the cowling, like the hood for your bonnet for your car that goes around the engine. It's a piece that can be taken off so you have access to the engine to work on it. But I had to make this mold up in order to make this. This cowling's only going to be like a 1/2 inch thick styrofoam, and it has to be fiberglass on the outside. And then once you pop it off the form, the mold that I make, you pop it off and then you fiberglass the inside, and then you cut pockets in it for little access doors so you can get to the oil to check the oil or add oil, or because this is a liquid cooled engine, there'll be a place to check to make sure the radiator's full, stuff like that. But it's the nose that goes right around the engine that, when it's on the airplane, because the airplane you see in the other videos, the engine's not sticking out on it yet, and that cover will cover the whole airplane, the whole engine, and then the propeller will be in the out at the very front of that. But it's a part that's removable for maintenance. It's built off the airplane. And that's kind of where I'm at right now. So as soon as the weather gets nice, I'll be finishing that piece up, and it'll be ready to go on the plane once it's goes back together for final paint job and everything.
How far will you be able to, I mean, I know you've got to do the 40 hours, but then how far can this plane fly on its fuel?
Okay, the gas tank is about 15 gallons it'll hold, which is, it's pretty close to 4 liters per gallon, maybe less, but it's 15 US gallons of gas. The engine will burn somewhere around 4 gallons an hour. And whenever you fly a plane, you're always supposed to have at least 30 minutes of reserve fuel left whenever you calculate flight plans for flying from point A to point B. You can't stretch the fuel out to the last drop. So basically at 4 gallons an hour, if you fly 3 hours, that's 12 gallons. It leaves you about 3 gallons of fuel. So you can go about 3 hours on 15 gallons of gas at 150 miles per hour. So you're looking about 450 mile range limit.
Whoa.
At 150 mile an hour. So you can do what we call cross-country flights with it fairly easy. I can fly it to Florida. Florida's like 2,000 miles. I'd have to stop 2 or 3 times for gas on the way is all.
And how fast are you going when you take off then? How fast in this would you be?
Takeoff speeds will probably be around 70 miles, 60, 70 mile an hour when it would want to break ground. And then once it breaks ground, then just climb to the point where climb outs will probably be between 100 and 120 mile an hour for climbing to get to your altitude that you want to fly at. And then once you level off, then the airplane will speed up. You pull the throttle back and you end up cruising about 150. And if you want to go faster, you just give her more throttle and open it up, and it'll probably top out around 200 miles per hour. But there'll be a sweet spot in there where you'll get your best fuel economy, just like in a car. You cruise 60 mile an hour, you'll get better fuel economy than 65. So airplane's no different. You want to find that happy point of how far you're traveling based on how much fuel you're burning. There'll be a spot in there where if you're going this speed, you'll burn this much gas and you'll get the best out of it. If you try to go faster, it'll burn more gas. You try to go slower, it'll burn more gas. Because there's a sweet spot in there that you got to find for ultimate fuel economy.
And how high are you flying? How high can
this
you go?
plane here, most people will probably fly between 3,000 to 5,000 feet with a aircraft similar to this. You can't fly more than if you go over 12,500 feet, that gets you up into the instrument flying zone where you have to be an instrument rated pilot, and you can't fly above 12,500 feet. But mostly, once you get over 10,000 feet, you need oxygen. So you need an oxygen supply. But there's limits to where you can go with the equipment you have on board. And this is just basically what we consider a sport plane. It's just a plane for flying fun, just for the sport of it. So mostly 3,000 to 5,000 feet is about all we really need to go. You don't need to go higher than that.
And you've made all those parts?
Yeah, everything was made from scratch. All the metal parts were cut out, ground, bent, welded, sanded, painted, plated, everything. The landing gear, all that stuff I made from scratch.
That's impressive. That is very, very impressive.
Trying to see which video you got playing. It's on a
One
small
about
screen.
flaps.
Trying to see what it is.
It says W.A.R. Corset flaps update.
Yeah, it's the course. I'm just trying to see which one it is, how old it was. That's the inside the cockpit. Oh, okay, that's the video showing the electric flaps. The flaps are what you put down to allow you the plane to slow down the slowest you can possibly get it to land. The slower you can make the airplane fly on landing, the safer your landings are. So takeoff, you want the flaps up because you want to get up to speed really quick and you want to get off the ground and get up to your altitude. But when you come in for a landing, you want to make it as slow as you can. So the flaps, you put down the flaps, what it essentially does is it makes the airfoil longer. It makes the chord length from the front of the wing tip to the back of the wing, makes it longer, gives it a bigger arc, which creates more lift and allows you to slow down without losing the lift. So you can come in at 60 mile an hour instead of 80 miles an hour on a landing. Without the flaps, I'd have to come in like 80 miles an hour to land. With the flaps, I can drop it maybe 10 or even as much as 15 miles per hour. So, and that's where most of the accidents for aircraft will happen either on takeoff and landing. So the slower you can go when you come in for a landing, the better you are. That's why, jet planes, they have flaps in the back and they have the leading edge wing slats that actually come out and go forward to make the wing really long from front to back. That's what you call the nose of the wing airfoil versus the tail of the wings. You make it longer, it creates more lift and it allows you to slow down, but it's a lot of drag. So it takes a lot of power to maintain flight. If you try to climb with that, the airplane won't climb because it has way too much drag until they retract the leading edge flaps and the back of the wings flaps. Once they come up, the air wing gets streamlined and now it can travel at a much faster speed with less drag. It's all drag versus lift in airplanes.
How heavy is the plane?
Yeah, once I got out of the Marine Corps and got the job at the local airport, I got my private pilot license when I was working there too, because they did flight instructions. And being that I worked there, I got a real cut rate price on the plane rentals. Fuel prices were cut down to just cost what the company paid for it. And my flight instructors I got for free. I didn't have to pay for that. And that was normally like $35 an hour for a flight instructor. To get a private pilot license in the United States, it requires 40 hours of flying time. Out of that 40 hours, 20 hours has to be dual instruction, meaning you have to fly with an instructor for 20 hours. And then you have to also fly another 20 hours solo by yourself. And that's the minimum time that you need before you can go take the flying exam with the FAA inspector to get an actual pilot license. So, and most people will take 12 to 15 hours before they're able to do their first solo flight, because first you got to learn how to start the plane, how to taxi it, how to take off, how to get up and maintain altitude and do turns and banks, and a lot of stuff you need to learn. So the faster you learn that, the quicker you can get to the point where you can fly by yourself, which is, the ultimate goal is to fly by yourself without anyone else. So you get up there, and then once the instructor, you can take off and land, and the instructor doesn't have to talk to you or touch the aircraft. Then he will sign your logbook saying, okay, you are qualified enough at this point that I feel you can solo the plane. So then they sign off, and then they let you take off, fly around the airport a couple times, do some landings, and then you're done. And then you just continue with your training. But it requires a minimum of 20 hours of dual instruction, no matter how quick the flight. Like I did mine in 10 hours. I soloed in 10 hours, which is really quick. So most people, like I say, it'd be 12 to 15 hours before they can solo. But even after you solo, you still have more dual instructions. They got to teach you how to do long cross countries and everything else. So, but you got to have 40 hours minimum. And when I went and took my FAA flight exam, I was right at 40 hours, you know, and at that time, my what they call a student pilot license, it's nothing more than a certificate that when you go take the written exam, to pass the exam, then you have to take a written exam like anything, a test. And then once you pass that, that is your solo pilot. That's your pilot's license. Your student pilot license is what that is. So then once you have that, then they can start teaching you so that you're flying with that little certificate. Well, that only holds for 2 years. After 2 years, it expires. Then you have to go retake the test or go take your flying test. So my exam was running out on its 2-year time period. So I had to hurry up, and then I was able to finish my flight training, and then they let me go take my test right at 40 hours and then passed it with flying colors. And then the inspector, I remember he was a real old timer, little old guy. And he says, well, he says, when you leave here today, you'll have your pilot license. He goes, but it's not a pilot's license. He goes, it's a license to learn how to fly, because you never stop learning when you're a pilot. You're always learning something new. You always learn something. So he says, it's not a license. It's a license to learn how to fly. So I got mine at 40 hours, right at the minimum time required. And I soloed it a time that most people can't even do. So I was just born into it. That's all there could be.
Yeah, it's in your
Let's
blood,
see.
I think.
Yeah, I've
You
just loved airplanes ever since I was a kid.
Yeah, Adventures in the Sky.
Yeah, ever since I was a kid, I just loved airplanes. And then the Corsair came about when over here in the 76, they came out with a show called Baba Black Sheep. It was based on Marine Corps pilot Gregory Boyington. They called him Pappy Boyington. He flew in the South Pacific against the Japanese. And this is the aircraft he flew. Well, they had the TV show. It lasted for like 2 seasons. And I'd never seen a Corsair before in my life until I watched that TV show. And I just fell in love with the airplane. And then I decided I'm going to build one of those. And that's what I'm doing.
And how long has it taken you again? Because I know that you've mentioned it before. But
Yeah,
someone in the chat.
because of my because of my I do all kinds of stuff. You know, I was into hunting and all that stuff, archery, shooting. I'd had a lot of hobbies, and the cars, the Mustangs, the drag racing, it kind of pushed the airplane project to the side. But this year, come June, it'll be 30 years since I've started that airplane. It sat in storage for like 6 or 7 years for a spell there. I just never, just kind of lost interest in building it because it's such a long thing. If someone was to start building this airplane and had everything they needed to build them, they still estimate like 2,500 hours to build it. So it's time consuming.
Right.
And I've made a lot of changes, modifications to it. I've made things better and added things to it that only extends that time even further. But I'm pretty good at building things that I can build stuff a lot quicker than most people can and a way lot better than most people can. But because other things always got in the way, I never really got into it. But now I've decided I'm going to finish it. So all these videos that are on there now of the airplane, I didn't have that stuff available 30 years ago when I started it, but I got pictures, old 35 millimeter pictures that I was taking of the project the whole way, but now I'm video documenting everything. And then I put it out there because nobody's got any videos out there of these war aircrafts. This is only one model of the airplanes that you can buy plans for. You can buy the plans for the P-51 Mustangs, P-40 Warhawk, Japanese Zero, the British Spitfire, the German Focke-Wulf and Messerschmitts, and there's another one called Sea Fury. So there's all different kinds of models of airplanes that you can build exactly like this one. It builds the exact same way, but they look just like the others. So you can do a Spitfire if you want to build a Spitfire. Half scale.
That those panelings, it looks like wall insulation, styrofoam kind of thing.
Yeah, that's all it is. It's just blue polystyrene or
Oh, right.
poly.
Okay. I thought it looked like
Yeah.
that. Yeah.
Yeah, it's the same stuff you buy at your local home builder supply house. Exact same stuff. If you pour a little bit of thinner or gasoline on it, it melts. You know, it dissolves. But the
Yeah.
foam is basically there for structural. It's non-structural. It's there to give you the shape and contours to make it look like the airplane model you want to build. Each model all has the same type of wooden box structure underneath the foam. It's just the different shape of the foam, which makes it look like a different aircraft. And then, of course, the Corsair has that gull wing to it, but everything else is a straight wing. But they're all built the same way. And that styrofoam, there's many different types of styrofoam you can use, but this is the same weight of polyurethane foam that they call for, but it's not necessary. The fiberglass cloth that's laid on top of it after it's all shaped and sanded with the foam, that becomes the strength and it seals the foam up. So it, as long as you don't get any fuel leaking down into it, it won't dissolve any foam. The fuel's limited up in the nose of the plane, and that's all sealed up. But all the airplanes like the Rutan company, Burt Rutan, remember the Voyager that flew around the world? They made that airplane, did a nonstop flight around the world. That's built the same way. It's just foam and styrofoam and fiberglass, stuff like that. It's a composite plane, same principles. And he uses a lot of this particular foam in his models.
Right. When you put the glass fiber on it, fiberglass, when you put glass fiber on it, do you have some sort of resin afterwards to, like, you know, make it even smoother, or is that like more or less finished and you just need to like sand it down and make it all nice and smooth?
Yeah, the fiberglass cloth is just like any other kind of cloth, but it's fiberglass weaves, threads, and you can get them in various thicknesses of cloths. You can get real thin stuff that you can put on model airplanes. It's as thin as tissue paper, or this heavier stuff for this airplane. And this is still just a really lightweight fiberglass, but there's two layers of it, and it's you use a two-part epoxy mix up with like regular epoxy glue you would buy for repairing a broken handle on a coffee cup. You know, the stuff you buy in a but I buy it in gallons. You know, I buy it 4 gallons. But you mix it up and you put the glass on there, and you put this on there, and you just squeegee it all out, and it soaks into the glass, and you put a nice even coat on it, and then when it cures, it's rock hard when it's finished. But then it still needs to have a final finish done to it after that. And that's where you come
Looks
in with
awesome.
this like Bondo. Yeah, there's a stuff called micro balloons. It looks like talcum powder, baby powder. It's microscopic bubbles, real like little tiny glass beads, and you mix that in with the epoxy, and it makes a thick like paste, like frosting. And then you mix that up and you smear it on that glass now, because that fiberglass, you can still feel the weave, the pattern of the fiberglass weave. And it's real shallow, but you can still feel it. It's kind of rough in texture. So you spread this stuff on there, let it cure, and then you get out and you sand it smooth, and then it's ready for primer and paint. But it's a very, very lightweight filler, and you use very little of it. Just enough to fill in the texture and make it a nice smooth plane. So when it's done, it'll look like a seamless airplane. It won't look like the real one. The real one's aluminum that's all riveted together, overlapped panels here and there. This is all one continuous smooth body line with no bumps and rivets and seams sticking out for drag. So it's actually a more aerodynamic airplane than the original. But yeah, that's my next thing. That's what I'm going to try and finish this year, is get the filler put on there like Bondo, smooth everything off so it looks like glass, and then I want to get all that done and get it painted and set back up right, get the engine back on it, get the instruments in it, throw the paint on it, and call the FAA.
Yay! For you.
So once it's done, you know, if you keep, like I say, if you keep checking back in this summer, you'll see the progression from the last video. As I go, I'll get the cowling made. Then I even have to make the canopy, the bubble part that you sit in, the clear piece you look out of. It's a two-piece. It'll slide open so you can climb in, and you pull it shut like a door, latch it, take off. I still have to make that. That's made out of plexiglass, plastic.
You'll have to come back and tell us a bit more about it, Don.
Yeah, Well, the plexiglass is a canopy. It's a bubble shape. It kind of looks like a little bubble.
I meant about the project, getting it flying, and we'd like to hear more from you about it the summer goes on.
Oh, yeah, not a problem. Yeah, it's been here. Like I say, right now the temperature's finally warming up. We've had some nice days here, almost 70 degrees here last week. Beautiful days, but there's other things I was messing around with. But yeah, I'll be back on it here. Like I say, I'm going back to work next week, and then I usually just work on it on the weekends. But yeah, the weather's finally getting to where I can get out there. First thing I got to do is clean the shop out because it's been dirty from all this work that I've done up to this point. I haven't cleaned the shop yet. So first thing I'll do is go in there and clean everything out, get the dust out, and then I'll finish up that cowling that you've seen me. And then I'll have to make a jig to start working on canopy. But once the weather gets up to 70 degrees and will stay that way most of the day, then I'll be getting out the epoxy to finish the work on filling in all the little depressions and nicks and dings and scratches and stuff like that to get it ready for paint. All the control surfaces, the parts that move that make the airplane steer, the ailerons, the elevator, the rudders, and the flaps, they're all made and cover. They all are built up in styrofoam. They're ready to go. They're all shaped. All I have to do is fiberglass those too. So I got to put 2 layers of cloth on them. So those still have to be covered, but I plan on getting all that done. That stuff goes fairly quick. It's just, what's going to be time consuming is the fine detail it's going to require to sand everything down, all the corners and edges, and getting it all filled, all the pinholes and little scratches and dings before it can be painted, because paint doesn't hide anything. Paint brings out every defect there is. So if you want the plane to look nice, you got to put the detail into the prep for before paint. So that's where I'll be working this summer, but I'm hoping to have the paint on the plane by the end of summertime. And then hopefully next season it'll be ready for its maiden flight.
Jay, do you want to say something? Any questions to ask? Jay?
Yeah, I've got one. It might sound stupid, but you don't have to have a flight recorder on there, do you? Black box.
No, this is an experimental amateur built aircraft. The only thing, when you start getting into aircrafts that have 2 seats or more, like my little ultralight that is a 2-place, it has an ELT in it, which is a emergency locator transmitter.
Yeah.
That's required. The airplane has that. So if you have an accident and you end up crashing, come down in some woods, the thing will kick on, send out an emergency signal, and then they can track you. That's required. But for a single seat aircraft, none of that stuff is required. You don't need a transponder or anything like that. But if I want to fly that into like Pittsburgh Airport, then I need to install a transponder to fly in.
Gone a bit muffly. Oh, that's better.
Yeah, your mic dropped
Can
off
you say that
then. I
last
was gonna say, like, you need to have a radio, don't you, to contact towers and things, or what?
You say again?
Can you hear me? Yeah. Do you need to have a radio? Surely you need to have a radio in order to contact traffic control and towers and what have you, don't you? Or don't you?
Yeah, radios. I have a radio. I have a handheld transceiver, like a walkie-talkie. I have one of those that I plan on using. But no, you don't have to have that. That's only required if you're flying into a controlled tower type airfield that has controls. It's not required. I don't need it. If I just fly from my private strip to a friend's private strip and stuff like that, it's not required, no. But if I want to fly into any airport that has a tower, a control tower, then yes, you have to have a 2-way transceiver radio, which I do have a handheld. This airplane is so small, the cockpit's so small. You don't have, well, the radios nowadays are pretty small. You can get them to where they're like 2.5 inches, 50 to 75 millimeters in diameter. They fit into a real small pocket now. So you can get dash mounted radios, but I have a transceiver that's like 5 watts. It's this equivalent, and it works just fine. And then I can take that out of the plane with me. I don't have to leave it, or I can mount it somewhere and leave it permanently in the airplane like my other one. But yeah, you still need a radio to go to any controlled airspace. That's the minimum. And then there's the instrumentation. There's a minimum requirement of instruments that you must have. You must have an airspeed indicator, an altimeter, so you know your height, and some type of turn and bank instrument that tells you that you're turning, climbing, or descending. A simple turn and bank indicator where it has a little like an airplane shape on there that just rolls left and right, and then there might be a little ball in this curved glass window in the bottom that tells you if you're yaw, if the nose is pointing left or right. That's bare minimum. And then you need to have your tachometer for the engine, oil pressure gauges, and stuff like that. But there's like 3 or 4 instruments in a compass. You have to have a mechanical compass. So there's a minimum requirement of instruments, a bare minimum.
Jay, did you want to say something? That's about
all these planes.
I actually have to go soon. May I jump in? I made a interesting connection with this awesome man. Is that okay?
Of course.
Yeah. So the Corsair. This is pretty cool. So it's a famous ballet, and I'm going to try to show this picture. Let me see if you can all read. Can you see this writing here? It should say Corsair somewhere in there. You're looking for, you see it?
Oh, yeah.
Okay.
Yeah.
Ballet. Now that's me when I was 19 dancing with a beautiful girl. It's called the Corsair Pas de Deux, like that man's plane, okay? So what I like about when people are talking about things that I might not be versed in, as a syncretist, I always hear something where I can chime in with my astrology to find the many names of Shiva. Now, Corsair, I'm going to share one more photo just to unite with this awesome man's presentation before I go teach my babies. Let's go to, okay, Corsair right here. Okay, etymology, really cool. Okay, can we all see that?
Yeah.
Corsair, and then Kronos. Okay, Kronos is a Titan. And when we go to the Titans, one second, you'll find out who everything is about very quickly. Boom. Can you all see the Titan and Saturn?
Yeah.
Yeah. Okay. So basically, what I'm coming to understand as I'm hearing other people speak about different diverse all called syncretism, and Saturn is a very popular energy that I know that these men who pretend to be, you know, astronauts. Before that was the men of fire. Pirates were your astronauts. The men that went sailing around like Sir Francis Drake, and they made the universities. So they made these ballets where they honor these gods of fire, like Saturn, who's known to be, of course, Satan. But when you're speaking and you're saying Corsair and then the plane, it gives me another understanding of all the names of this God that everything is about. All religions talk to this Shiva. You want to call him Nimrod, whatever, Zeus. There's so many things. And so Corsair was my connecting thing. And I just wanted to say thank you, man, for your awesome presentation. Because when I was young, I wanted to fly. That was what made me want to do ballet. I teach ballet, esoteric ballet. So that was my thing. I wanted to be like Superman. And I would always jump off my house and try to get wings and fly. And you actually gave me another aha moment. The plane is the shape of a crucifix or a compass. The Nordic cross, the X, is a symbol of the earth. So the body or the crucifix in symbolism, and this isn't to challenge organized religions at all, I'm not saying anything bad, just symbolism. The plane, I had an aha moment, is the flying crucifix symbol or the Nordic cross of the earth or the body that we all have. We all have the compass. So when the plane is flying, it's a symbol of our bodies. So I just wanted to say thank you. A lot of aha moments and just great to meet you. Your name again, sorry?
Don Gable.
Don Gable.
Donald.
Fantastic, man. Donald. Yeah, I'm gonna head out, but I just want to say thank you, and I hope that those connections were interesting to you. That's it. Yeah.
Yeah, there always seems to be some message, some meaning behind a word. It's like Transvault is the company that built the Corsair, and who knows where they got that name from.
Yeah, and I'll show you one more thing actually about hydrogen. Hold on, let me get into that quickly. Yeah, this is pretty cool because hydrogen also. So in etymology, hydrogen actually relates to water or birthing, and of course it's the goddess water. Women are a symbol of that. When you click on gen for hydrogen, you get oxygen. Now, when you look up oxygen, these are the words I love to find. You find these two letters, AK. Now, this is an important name because I'm going to show you who this is. This is a very famous pharaoh. 1 second, I'm almost done with the first two letters, AK. It would be, hold on, boom, 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 boom. This guy right here, bam. Can we all see Akhenaten, Akhenat? This is the first pharaoh of Egypt. This is the big guy who made everything change in Egypt, and he went from one place to another. He wanted to focus on the sun. So your mysteries of the pyramids and all that, these are men who pretend to be your elements. So Akhenaten was the sun god, but clearly he also wanted to be the god of oxygen or simply air. And so I just, yeah, when he was talking, I was looking words up, and then when he said Corsair, I was like, oh shoot, that has to be Saturn. So yeah, I went on my little investigation, and I was just really grateful, man, because there's a lot of stuff in planes that just, I mean, with mythology and the body, it's amazing.
Yeah, sure is. Thanks for that.
Yeah.
Appreciate it.
Yeah, hey, man, that's what I'm a syncretist, and I'm grateful that I can be silent and just be patient and let someone speak, and I can hear one or two things, and then I can just add in and say, hey, thank you. So can we say that we're dancers on the count of 3 before I go?
Yeah.
Dancers on the count of
We have
3.
to do that now.
Dancers on the count of 3.
Okay, so yeah, all of us have to say it because we're all dancers. Okay, here we go. Very, very slow. 1, 2, 3. We
dancers
are dancers.
Dancers.
Yes.
Yeah.
Well, that was shoddy. I think we should try again tomorrow.
Because, we have the tribe of Dan and dancers. It's one of the 12 tribes. We have 12 cell salts and 12 body functions. We are the tribe of dancers. Bam! In your face. Ah, flat earth.
Oh, thanks, Jay.
Thank you, Karen. Much love.
Thank you, Jay. Hey,
Thank
Jay,
you,
by
man.
the way.
Yo.
You could see I was a dancer today, couldn't you?
Of course. Come on, man. You were like, what?
No, that wasn't me.
Astral.
That wasn't me.
It was your spirit.
I was the one spinning around on the floor, man.
Oh, wow. You got to be careful, man. You gotta warm your neck up first. Might hurt something. All right, Jay is flying. How do you say signing out in airplane lingo? T- and counting out, or what do you say?
Oh, what was it? Over and out, Roger Wilco. Over and out.
Over and out, Roger. I like it, Roger Wilco. There you go, buddy.
Thank you, Jay.
See you
Love
around.
you.
Peace.
Cheers, Jay.
Yeah, he's off to his ballet class.
Thanks, Jay.
Lev, do you have any questions? Have you got anything you'd like to say to
I
John?
have to go. Well,
Oh, you have to go.
yeah, I told you I was going to go at about 11.
Yeah, you did. Time's just gone so fast.
But no, brilliant presentation, Don. I hope to get to meet you again, and I'll catch you all later.
Bye, Lev.
Yeah, take it easy. Take it easy, Lev.
Bye-bye, Lev.
Bye, darling.
Bye.
Love you too. Have a nice time. Yeah, he has a friend coming round. Astral, is there anything else you'd like to ask Don then? Astral?
No, I think I've asked all the questions I was just interested in earlier, but I take my hat off to you. Well, if I had a hat. You've done a fantastic job there, Don, and I can't wait to see it when it's finished. I really can't. I mean, you're a true genius, brother, really. I mean, anyone who can build a plane, that in my eyes is a genius. So I congratulate you on that. And I look
Every
forward to
single
seeing
piece
it.
of the plane.
Yeah, I got that skill set from my dad. He was one of those jack of all trades, master of none. That's what I call myself. I'm just really good at with my hands. I just love building things. I have this mechanical mindset that I can understand anything when it comes to mechanics. It's just that's why I think flat Earth works so easy for me.
Yeah, it's really
Yeah.
good.
It's the way it is.
Yeah, lately I've been listening a lot to the flat Earth debates with Nathan and Anthony. I've been kind of caught up in those guys for a while.
So can you explain to us like how you got into flat Earth then? Because obviously you were sort of
Well, I've spent a lot of time on YouTube, you know, with uploading all my videos of airplane stuff. So I'm always looking at aircraft stuff, but it's just so few things on the internet on YouTube for airplanes. There's a little more now than there is, but there's still not a lot. But so I go in and watch a lot of things. I do a lot of research whenever I want to build something or I need something like for the airplane that normally people would just want to go out and buy and pay for because they don't want to build it. Me, I'd rather build it. I want to know how do you do that. It's like this next part of the project is going to be making the canopy. It's going to be a vacuum forming process to build the canopy, the clear part that the bubble canopy that you look through. So I'm going to be learning how to do that. But I'm always watching videos on vacuum forming and mold making and things like that. So I'm always watching videos.
Hey, I know a little bit about that. You use acrylic, don't you? You need to heat it up in a kind of an oven with, you know,
Yes.
hanging on some kind of clamps or whatever. Yeah, because a
Yes.
few years back, I was making skylights. Yeah, and
Yep.
they were blown from underneath. You put it on a table with a cloth on and blow it from underneath with air, and then have sensors
Yep.
to the height you wish it to, and then it'll cool a little bit, and then it'll blow up again, cool a little bit until it hardens. Yeah, very simple.
Yeah, I've watched. That's the blown process, the blown method. I'm probably going to be using the opposite of that. If you use the mold instead of blowing it up, or if you have it pointing down, it's easier to blow it down. Put the air pressure on the top and force it down. With that design, it's better to heat the air that you're going to use to blow the bubble with, because cool air coming in onto the warm, hot plexiglass will try to cool it while it's trying to stretch at the same time. So you preheat it. And then the other option is when the plate's standing there, whether you blow it up or you use pressure to blow it down. If you use vacuum, you suck it down into the mold, and then you can regulate the vacuum to pull it down. And the vacuum does a nice even pressure, and you're not using a blast of cold air to try and form it with. So a vacuum is just the opposite of just what you said there. But yeah, I've been looking at all those methods and procedures, and I've decided to go with the vacuum forming procedure. So I have to make basically a male plug mold of the canopy shape, and then take that and make a fiberglass mold over it to produce the female mold. And then the female mold will be used to do the vacuum forming in. So that'll be a project for this year as well.
Sounds interesting. Sounds exciting.
Yeah, so that's what I was doing. I was watching a lot of videos like that, and then one day this video pops up for the Go Fast rocket, and it was the thing. It was the icon was showing hitting the dome in 3, 2, 1. So I'm like, what is this? So I click on it, watch it, and it's just a rocket launch, and I see this thing go up, and then it says, okay, hitting the dome in 3, 2, 1, and you hear the boing, and then it stops and starts falling. I was like, what in the world is that all about? And then as I'm looking at it, I was like, flat Earth. What is this flat Earth? You know, I've known about flat Earth, you know, just like everyone else as a kid in school. Yeah, people in the old days thought the world was flat. Well, I did too. So one video just led to another. And that was about a year and a half ago. It was the end of last fall, I guess. And then I started, and then just, I mean, it was just like for 2 weeks nonstop. That's all I watched, YouTube, flat Earth videos. You know, I got to see all of Jaron Isms and Mark Sargent's, and I didn't even know any of those guys at the start. I just saw that Go Fast rocket, And then I just started watching it, and it led from one to another, and then that was somewhere around November, I think, of 2016. Yeah, 2016. So then I went to seeing that the Flat Earth Conference was going to happen, and they were selling the tickets early. So I taken like, what the hell? Let me go. I buy my ticket, and that was in February. And then I didn't, the thing was in November. So the rest is history. Anybody still hear me? Hello?
Yeah, we can still hear you.
Okay. All right. It's just a little quiet there. So I can still see my video moving from mine. So
Karen's probably fallen asleep. Is that her snoring
No,
now?
I haven't. I'm sitting here. It's just that I couldn't unmute the button quick enough.
yeah, it
Yeah,
was
it's
just
very.
the Go Fast Rocket, and I can't remember. I mean, I've probably watched thousand videos plus now. It's all I do every day is get on YouTube. I watch probably 99% of my entertainment on YouTube now. I don't even watch TV.
No, none of us watch TV anymore.
But I still like going to see a movie. I still love Star Wars. I'm big Star Wars. That was the first movie I ever saw in a theater when I was 14. I think I went and saw Star Wars in the theater. The first movie I ever saw. I've been a big Star Wars fan, but it's science fiction. That's all it is, science fiction. And I see it as just that. I don't see it as reality. I mean, after, in the 50, 60 years since NASA started, they haven't gotten very far. They've gotten really far in CGI, though.
Yeah, agree with you on that one.
Yeah. So how's my phone been working for this whole thing? Has it been all right, other than a couple of volume issues?
I'm not sure if you just put your fingers near the microphone and maybe it muted it a little bit, but apart from that, perfect.
Okay, that's good. Like I said, what happened, I guess, when I was trying to get on the first time with you guys, the phone, I had the app installed for Google's Hangouts, but it needed the approval through the phone to share the microphone and stuff, video stuff like that, and I didn't have it set up to do that. That's why the mic didn't work. It didn't have the approval from the phone to use with the app. And I finally found that in the settings, and that's what I changed. And it seems to be working just fine. But when I joined Antonio's one of his first sun tracking sessions, I had to call Chris up on their side chat channel to verify that I actually had a sundial set up. They didn't want anybody crashing their hangout, so they send you to a temper hangout. When I called into that, it worked just fine. But I think because I made the call in, the voice and everything worked fine. But then when I tried to work with you guys to go on, you contacted me through it, and I think then it wouldn't work that way because the video was working, but just no sound. And I didn't change anything from Antonio's hangout to that last hangout with you guys.
I don't know what happened there. You're really good now, so that's.
Yeah, my internet service here is too slow for video. Like the last one, I used my laptop on it, but I wanted to see if I can get the phone to work because it's on the network and I've got a good cell tower close by. And then when the wife comes home and wants to use the internet.
You haven't built a network like that, have you, after all the building you've been doing and the experiments you've been doing?
What was that again?
I was just saying, you haven't made one of those as well, have you, with all the experiments you've been doing? And
oh, yeah. No, this stuff's a little over my head. I learned a lot about electronics with the Stan Meyers research, a lot of electronics. I knew what the basic components were. I knew what resistors and capacitors and things like that were, but I didn't know anything about the RLC, the LRC, the inductance, capacitance, resistance circuits. I knew nothing about that. So it was a learning curve, and I've learned enough that I've fixed some electronic stuff before that I would have never been able to fix before, just from this knowledge that I've gained. And that's like me. That's all I do is I just read stuff. I read stuff, learn, and practice,
Hey,
experiment.
Don, I've got a job for you. Tack Mind in the chat room says, can Don map the north with his plane from Canada to Russia or Norway, etc.? Can you map it for us correctly?
Yeah, that would be nice, but I don't think I could go that far with this plane. North, it wouldn't handle the cold too well. Even though it's got some heat, but yeah, it'd be neat, but nah, that's nothing I could do. I don't know anything about mapping anyway, but I see his point. I'm more interested in seeing what the South looks like, you know. But everybody knows what the North is like. It's just the South Pole that seems to be our problem.
Yeah.
Well, we
Don,
don't know what the North Pole really looks like, do we? No, we're not even sure what that is, or even if that's there anymore. I mean, I have said this before, but my one of my daughter-in-laws, she comes from Lithuania. And for 6 weeks in the summer, they go up to the Baltic Sea, which obviously is like looking out towards the North Pole bit, and they have summer holidays up there. In fact, it gets to 40 degrees. It's hotter there than it is here. So I just think they're lying about everything. Because you've got France, the Alps, then you've got Spain. Hot France, cold Alps, hot Spain. The Himalayas, they are in a very hot country. That bit's cold, fair enough, but it's in a hot country. So I just think they're lying about everything. There's
Yeah, what
going to be
really
hot and cold places.
what really piqued my interest was when Jaron from Jaronism was saying, given his description of like anything north of 60 degrees in the northern hemisphere is, you know, there's plant life, there's food, there's animals and stuff like, you know, people live up there, can live up there. But when you get, you know, it has plants and it had plants, life and all that. But when you get to 60 degrees south, it's a desolate, barren iceland. Nothing's ever grown there. There's no history of plants or animals of any kind. And if the world does what they say it does, tilts through the summer and winters, they should be the same up and down. The top should be the same as the bottom. The bottom should be the same as the top. So that there is odd, you know, if it's...
yeah, well, isn't the sun also closer in the winter than it is in the summer?
True, yes. That's
And there's
another
like
point Jaron makes.
like what's going on there?
3 million
Yeah.
miles closer in the winter than summer, and that don't make any sense.
Isn't it the higher the sun goes, the warmer it is, and the closer the sun is, the colder it is?
That's what they're telling us. Yeah, that's what they're saying. At least in the northern hemisphere, that would account for. Because
But
in
then
the
if you
southern...
listen to that guy that we were talking about, the one with the videos with the distances, then actually the sun ain't very far away at all. I mean, we're talking about a
like
mile or two.
Who is it? Is it Jaron? Yes,
Your
Jaron also says that, you know, you can go outside in the summertime, middle of the day, look at the sun, feel the heat on your face. But then in the wintertime, you go out there on a perfect clear day and you look at the sun on your face. It's just warm. You just don't feel it. And it's closer in the winter than it is in the summer, but yet you don't feel it.
I know, it's a bit crazy, that one, isn't it?
Maybe it's something to do with the dome above us is thicker, therefore in the summertime it's giving off more heat, and in the wintertime the dome is thinner, or whatever, vice versa. I mean, you know, I don't know, am I talking stupid now?
No, I mean,
like the thickness of a lens, I'm thinking, you know, maybe it's...
Or like some people think, I think maybe Bob from Globebusters, maybe Jaron thinks that the North Pole, the dome, if there's such thing, is lower at the North Pole, and then it humps up as it goes across the equator to the South Pole. So it kind of looks like a bundt cake pan upside down. You know, the funnel cake pan, where the center at the North Pole in the center.
One of the people we know, he used scalar waves, partly to do with an electricity company. And as far as he can tell, the firmament's 60 miles up, and it's a frequency. He can't tell if it's hard or not or solid, but it's a frequency 60 miles up, and everything's inside that. The sun, the stars, and the moon.
Yeah, like Mark Sargent says, it doesn't have to be very high. 60 miles doesn't seem very high, but it's high compared to what we go to. Airplanes, what, 10 miles up maybe? You get into the, the spy planes and stuff that can go to 80,000 feet. That's still only how many miles? 5,000. That's 40 miles is all. So yeah, 60 miles is could be logical point because everything we do is real close to the ground. It's not
And
very,
anyway,
very
they
high.
want to put what was that star? I forget what it was called now. Artist, do you remember the star?
Yeah, the Humanity Star, was it?
No, they want to put one of those up there. How could they do it if it's trillions of light years away and have this thing flashing on and off through the sky? I mean, they can make stars. There's two places to make stars in South America and Germany. And they can't get any higher than 60 miles. You can actually find those on the internet. But the machines they've got would work further, but they just can't get the stars and to make stars any higher than 60 miles. So it looks like there's about 60-mile barrier up there.
Yeah,
There's definitely
be
a
limit there.
frequency.
There's got to be a limit somewhere. And even Mark Sargent says, even if you get to the Antarctica and get on shore and start going out, he feels that, you might have to travel 2,000 miles before you find the edge of a dome. So, because look at Admiral Byrd, how many years he searched and searched until they finally must have found something or gave up.
Well, according to those, he traveled like thousands of miles down.
Yeah, and he was out for what, 20, 30 years trying to find something, and the resources it takes, because you can't just drive out there because you need fuel, so you got to keep stocking and stocking, making steps and steps and steps to get farther and farther out, and it just took that many years to do it. And then you can imagine, if that's the case, the weather can only get worse if there's no sun out that far.
Yeah, pretty cold. Well, we can live without the sun, I think, but it'd be pretty cold.
Yeah,
it'd be pretty
for a while until nothing grows, nothing left to eat.
Or maybe the moon helps on that one.
Yeah, that one's what I really found interesting was the cold light that the moon puts out. That's interesting.
Yeah.
I haven't tried it, but I haven't tried it myself, but I see a lot of people have done it, and they pretty much come back with saying that, yeah, I've seen it. Even Zulu One from New York, Mark from New York, he calls in Mark Sargent's show all the time. He was called in and was talking about his test, and he saw it with his own simple little test with his laser pointer. That, yeah, he says he was seeing a difference in temperatures, and I figure, well, I can do the same thing, but enough people have done it. I don't think I really need to. I'm convinced. If I want to really convince myself, then I would do it. But certain things, everyone says, oh, you're just listening to YouTube. It's like, well, they're showing pretty simple facts.
We've got a new project on the way as well. Oh.
Which one's that?
Well, we were with Mr. Thrive and Survive on Friday night, and he was just there for a catch-up, really. That was it. I thought he was coming on to give us more sort of information about Q and all that. And he said, no, I've just turned up to listen. And by the end of the evening, he'd bought a web page called, well, it had to be changed because he bought .com, but there was a mistake in the wording. So it is now www.peopleforpeople.life. And it's going to be a web page set up for anybody in the world, hopefully, to go and look at instant, in your community, medication, education, chats, talk, listening, posting. And it started on Friday. So yeah, we're all very excited about that. It's somewhere you can put information on to help people.
Yeah, I've been watching his videos when he put them up, and I think he was referencing that a couple of times, talking about something he had in the works. And so, yeah, that kind of sounds like what I think I heard him talking about.
Yeah,
Yeah, I
something
didn't catch your thing with him yet. Yeah, I remember him talking about it because I keep an eye on his stuff too. I watch him when he posts because I know he's into the medicine. He just bought that stuff for his shoulder pain problem he's had. He's been taking, and so I know he's into that type of therapy. Getting away from
alternative. Yeah, and
alternative medicines.
just somewhere so you could also go and look yourself and maybe sort yourself out much quicker and better. And it was a bit like, you know, like, hey, we asked Don to come round to make us a plane, and then for him maybe we can, I don't know, give you some vegetables, mow your grass, and try and get a community back in your own community. Your community will react quicker to you than the police and everybody else. So
Sure.
yeah, and a network for people. The people need this kind of network. We don't have it anymore. And yeah, it's obviously a big project list, but yeah, it was born on Sun and Moon.
I guess the biggest thing is getting the word out, getting the word out to the masses so they start using it. It's got to start somewhere, but yeah, you got to get the word out.
Yeah, well, I've made a little video about it, and I should be reposting it so that hopefully the word does get out. And obviously we'll have to have maybe more hangouts with him and talk about things. So it's great, but it's for the people, which makes a change, isn't it?
Sure.
Most things are costing people.
Considering how Twitter and Facebook and YouTube are trying to shut everybody up and kick them out, people are going to need an alternative.
Yeah, and there might be a bit that you could put in there about flying. If people want to learn to fly or help do things, there could be a bit of Don in there as well.
Yeah. Well, I keep telling people I'm not doing anything for nobody else until I get this thing finished. I'm not going to, like these chapters I belong to from my flying clubs, they're always looking for someone to be the new president or the vice president of the chapters. And it's like, I'm not doing any of that stuff because it just takes me away from finishing my project. When I get this thing done, then I'm just going to kind of glide through the rest, and then I can put more time into stuff that requires energy like that. But I can only do so much when working on this plane. I mean, I got to spend 8 hours a day out there on the weekend to make any progress at it. So I just don't have time to fiddle with a computer half a day.
So how many hours do you think you've spent on your plane so far?
I don't know. It's probably could be around the 2,000. I write down every time I work on the plane. I keep track of how many hours I estimate I worked on. Even though if I'm out there for an 8-hour day working, I'll look and think, well, I really only worked maybe 6 hours. But
Oh, no. I think Don's phone ran out. Do you think that? Astral, artist, do you think his phone ran out? You're muted.
Asses has been having a bit of trouble as well, I do believe. He's dropped off and on, hasn't he?
Yeah, different countries though. Oh no. I was probably gonna, like, we've been going for nearly 3 hours. I was probably gonna sort of wind it down shortly anyway, but it's not, when your guest drops off. So annoying. But his phone might have run out of battery. He might come back in a minute on his computer. We'll give him a few minutes to see if he comes back. Amazing man, isn't he?
That I'm so impressed with what he's created there. That he's made all the components and parts by hand. Like, I mean, that skill he's a genius, really. Yeah, I'm impressed, very impressed. Don't forget your question, Karen. What you're going to ask him?
Yeah, well, he's just a clever man. And his plane, wow, to do every single piece. Plus, he got quite into Stan Meyers, and I think that I saw one of his videos and started talking to him, and then he came on Sun and Moon before Christmas. But he's a nice guy. And his little gyrocopter, that looks fun, but I still don't think I could go up in that. It's too small. There's not enough We need more. I need more around me. But yeah, he's quite. He likes flying, doesn't he? One way or another, likes the thrill of all these things.
Yeah, didn't you find it funny when Artis was showing the video of there was a car driving and he was like flying behind the car? The propellers, it almost looked like they were flying up and then down and up, and you know, what's going on there? Oh, because it was just the frame rate of the video. I wonder. I'm gonna
Yeah,
one
with my
asking that.
propeller blades look so funny. They look like they're going backwards. It's just what I think what propeller planes look like when you capture them on digital cameras. Is Artis there? Because Artis has been having a bit of trouble. Artis. Oh, he's back.
Hooray!
Yay.
There I
You
am.
made it
I
back.
don't know what happened. It just died on me. I was
No.
sitting here and died. It's like, well, I'm going to take advantage of this. I need to make a bathroom break.
Oh.
Yeah, I don't know. I
Well,
didn't touch anything. It just died.
sometimes you get kicked off on mobile phones.
Could be it. Nothing really came up. It just says you have left the call. And I was like, I don't know what that was all about.
Well, you were in the middle of telling us.
Yeah, I was telling you how many hours. Like I say, I got a log book. Every time I work, I write down how many hours I put in for the day or stuff. So I haven't bothered to count or add up the hours because I don't really want to know at this point. But when I'm done, I'll go back and count it. But like I said, the original plans were calling for they originally said 2,500 hours because it's time intensive. But then I'd heard revised statements saying, oh, you can do them like 1,200 hours. But I'll know when I'm done. But like I said, I've done so many different types of modifications to these plans as far as I've changed the airfoil and had to redesign the shape of the wings airfoils, had to draw all that stuff out and recut new patterns. And then add the flaps on this airplane. These airplanes don't have those flaps for landing. I've added those myself. So I had to design all that stuff. So that's all in addition to what the original plane would have taken to build. It would have been a little faster building it by the plans, but I wanted to try and slow the plane down because what we call over the fence speed when you land, like I say, every aircraft has a different landing speed. And this one, you had to be between 70 and 80 miles per hour over the fence. And if you got below that 70, then the plane could stall and, stall and crash. So I wanted to see if I can slow it down with the addition of flaps, and that's the whole purpose of flaps. But because of the bent curve of the wing, you have to do it in 3 sections to get enough flap area, 3 sections per side. So that's 6 pieces. And there's a lot of mechanical designing and engineering to go into there to make these 3 all work in sync with each other. And so that took a little time to design those.
Mm. Well, you must have a lot of patience there, Don.
Yeah, pretty much. I'm a pretty patient kind of guy. I don't get upset too easy with people. I'm not a big arguer. I just do what I got to do. I enjoy doing the work. If I ever lose the use of my hands, boy, I'd feel pretty much worthless.
The engine and everything works, doesn't it? You've tested all that bit.
Yeah. If you look at my videos, there's a video on there of the engine where I start the engine and run it before and after I build a muffler for it. There's videos on there of the landing gear doing its retract cycle. The gear on this folds backwards. It's mounted in the front and it folds back up into the bottom of the wing. But also as the wheel comes up, the wheel goes from this position, it rotates 90 degrees and then goes up flat. So when the wheel's up in the wing, it's horizontal like this. And then when it comes down, it literally has to, let's see how if it's up like this, it's going to rotate like this as it comes down, so it's straight pointing forward. So it rotates up and down. It turns 90 degrees, and then the doors will close behind it. So it's not just a simple going back up in, it goes up and turns as it does it. And I got videos on my channel that show how that works. It's pretty slick. And then the original design called for a little hand crank on the inside of the plane with a little chain and sprocket like a bicycle that went down into a gearbox that turns the shaft, and another set of gears which would pull the landing gear up and down. Well, I took all that mechanism out and I put in hydraulic cylinders, and now I made it hydraulically actuated. So the video you watch that video and you'll hear the pump kick on when I flip the switch, and you hear the whee, and then the gear goes up and wheels turn. It's pretty neat. Those videos are on there before there's any styrofoam even added to the plane. It still just looks like an old boat, a little wooden boat with some legs sticking out of it. And I got it held up with a hoist in the air so the landing gear can rotate freely. But all that stuff's on my YouTube channel. But the engine runs super sweet.
Yeah. So this is about the size of a car then?
Yeah, it'll be, it's 20-foot wingspan from wingtip to wingtip, maybe 21 feet. So that's, 7 to 8 meters wide. It's about 17 foot long, so it's about a meter short than it is wide. And the whole thing, when the gear's all up and down, you're looking at 1.5 meters. It's like 4 feet from the belly to the top of the tail in height. When you're sitting in the airplane, from my shoulder to shoulder, it's about 2 feet, 24 inches, maybe 2/3 of a meter wide. It's real tight. You kind of just slide into it like a shoe. It's small. And I'm 6'1",
How'd you get in it then?
so I'm pretty tall.
Little ladder?
Block and tackle, probably.
Yeah, you kind of have to, you step up into the airplane, you put your feet down inside, and then the instrument panel is right there, basically above your knees. So when you put your feet in, the wing spar comes through the fuselage, and it's probably 10 inches high. So you have to kind of get your heel up over that spar while you keep your knee from bashing into the instruments as you slide your legs down inside and sit down in. You basically sit in the bottom of the airplane. There's not much distance between your butt and the belly, which is maybe 4 to 6 inches is all the farther it is. But yeah, you kind of slide into it. It's like a glove.
Oh.
So it'll be a lot of fun.
Well,
But this airplane's capable of basic aerobatics. You can do loops and rolls and stuff like that. It's got a real high tolerance for G-forces.
yeah, I bet you can't wait to do things like that, can you?
Yeah, I want to be able to do, like the barrel rolls, the victory rolls, like you see in World War II, an airplane comes in and does a roll, victory roll, they call them. And then the loops, the up and over and back, stuff like that. Just basic aerobatics, nothing drastic.
Hey, remember, on a globe Earth, you can't do a dive because of the Coriolis effect. Or you can't dive down to a point, can you, because of the Coriolis effect?
Yeah, keeps moving.
Only on a globe.
Yeah, and then it's constantly moving underneath you. That's another thing that made me think too, like if the world's spinning like they say and the airplane's landing, because you have the problem of, well, they say you got to account for the Coriolis effect, the spin of the earth when you're shooting a bullet, but you don't have to do it when you're flying an airplane. It's the same projectile. They're both projectiles. So how can you have it for one but not the other? If the Coriolis affects a bullet flying through the air, a projectile, an airplane's the same thing. And when you come in for a landing, if you're not landing perfectly east-west, the runway is going to be moving one side or the other as you're trying to land. So as a pilot, you can understand those ideas. It doesn't make sense. If the world's spinning, it would be impossible to land on. Every runway in the world would have to face east-west everywhere because of the spin. You couldn't have any north-south, because if you're coming in for a landing, the runway is going to be moving to your right or to your left. And if you got an airport that's pointing in any other direction, then it's just now you got compound angles going on at the same time. So don't make sense.
So every runway would have to be pointing the same way.
Yeah, if it was a physical spin, the ideal runway would always be east-west, east to west. If you go north to south, then the runway as you're coming in for a landing, the runway is going to be moving to your right or your left if you're going north or south. And then if you got to land at a 45, now the runway is not only moving this direction, it's moving X and Y on the plane. So, and you'd have to compensate that for that on your landings, but we don't do that. The ground's steady and still as you coming in for landing. You can let go of the controls and it will just stay right there and come right down the end of the runway for you once you trim it. So yeah, it doesn't work that way. We don't have to
I
keep
saw that they were
moving.
trying to make. There's ideas about a round runway. What do you reckon of that then? After what you just said, a round
I
runway.
haven't seen that. Have not seen that. A round runway.
Yeah.
Well, around.
See,
I mean, if it's a big enough runway that would allow you to come in and land at any angle, so you're coming into the wind, yeah, that would work. But you're talking about a huge
I meant on your
area.
global.
If you need a
Globe ball,
runway
I
that's
meant.
say a mile long, 5,000 feet, you'd have to have a 3,000 foot diameter place to land, so you could come in at any position around that 360 degrees. That would be neat. That'd be nice. And then you'd never have to worry about crosswind landings. You wouldn't have to figure out any crosswind components for taking off and landing. You could always just
This
point the nose
captain
into
was
the wind and
talking.
land or take off.
This
Yeah, if
captain
you're
was
not familiar
talking.
with airplanes.
He brought up
So,
that one and he said that would be good, like the crosswind, but there were so many other areas where it wouldn't work. But anyway, it's just an idea of someone's. But I meant it more for the globe world. If all the
yeah,
runways have to, what you said, then how could a round runway work on the globe?
it wouldn't. It wouldn't.
It wouldn't.
You'd
It'd be a
still have the
nightmare,
same
wouldn't it?
problem. Yeah, you would still have the same problem. You would still only land east to west with the world moving around you, under you. But because they say the atmosphere is, like they call it, tattooed to the planet, it's fixed to the planet, but doesn't make any sense. If that was the case, we wouldn't have weather. We wouldn't have winds. We wouldn't have, it's not fixed to the ground. It's free of the ground. It moves on its own accord because the ground doesn't move.
The good thing about these little conversations now about, it's flat, it's not moving, there's no Coriolis. This video is going to be on YouTube for years to come. So hopefully people will look at it over time and we can convince more people that, yeah, we're not living on a bar, we're living on a flat earth.
Yeah, maybe.
So thank
YouTube,
you.
Yeah, YouTube is really starting to strike a lot of people. I see Jaron just got a 3-month strike again. He was not allowed to do any live broadcasts. He just got struck again.
Yeah, that's true. Yeah, and it wasn't even anything
So,
grim, was it?
no,
Got to be careful, man. But there's no
hate
freedom of
speech.
speech anymore, is there?
No, it's a false sense of freedom of speech.
Yeah, but I've been watching another truther. I won't say his name or anything, but he's also got a strike. Now he's going to, make a lawsuit against YouTube, Google. So that's good. And he's bound to win. He's got to win, hopefully.
Well, I mean, I'm sure YouTube's got a lot of terms and conditions in their contract that you have to accept, blindly, because nobody reads the stuff and no one's going to say, well, I don't accept that. And then they're not going to go on YouTube. I mean, they rely on that stuff. But yeah, I mean, the way YouTube's going, there seems to be a lot. They're really starting to come down on people for stupid things, just trivial stuff.
They gave me a strike a few months ago, but they didn't give me a strike. But I got the same result as having a strike. So I got no email, nothing to show on my panel, no strike, no nothing, but I still couldn't stream.
I noticed on one of my, I think when I just joined Nathan Oakley's Hangout thing site, I clicked on subscribe, and then I clicked on the bell notice, so it would send me notices when he's live, and it says you'll occasionally get notices. They didn't say that they would notify you on every instance. It came up weird that I read and it's like, they're saying, okay, they may send them and they may not send them.
I've seen that before as well. All right.
Yeah, but
That's
I think,
the
Don,
first time I seen it.
I think you just need to touch it one more time because it does do that sometimes. It plays a little game with you, you know. Yeah, just touch it another time and it should verify it, like, you know.
Yeah, well, I did. Yeah, well, I did click on. I was subscribed, but then when I clicked on the bell to get the notifications, it said It said in its essence that yeah, we'll notify you of some of them, but it wasn't saying it would do every one of them. Because I did that once for Alex Jones. I like listening to him at times, and I clicked on his bell, and I was getting 100 emails a day from it nonstop. So I finally had to click the bell off because it was just filling my mailbox full because he puts so many videos out. But that seemed to work just fine. But now with the ones that I am clicked on to notify, I don't get them all the time. So they must have changed that. That's the first I've noticed it when because I don't subscribe to people like that because I just don't want all the. Usually they'll pop up if I'm on the computer, but some of them haven't been showing up. I just don't get the notice.
Well, they like to make it difficult for us, don't they?
Yeah, I think they're gonna slowly and steadily crack down on things that they don't like or want to keep people away from. Earlier in the chat, you were talking about NASA and SpaceX. I think, like some are saying, that SpaceX is going to end up replacing NASA just because they can look like they can do it better and cheaper than NASA. So I'm thinking that NASA is going to slowly, silently slip on into the night, and SpaceX is going to become the dominant force to look at. And then if something really goes wrong, it's like, well, there's our scapegoat, SpaceX. They're gonna bury him.
Well, artist reckons you need a slingshot and a car. That's it to go to space now.
Yeah. I'm really waiting on the was it Lake Bolatran experiment with the FE core. That's supposed to be going on right now. I actually called in and talked to Jaron last week on his show, and he said they moved it back to the 20th because it was supposed to have been the 14th to the 28th on their website that they were going to be in Hungary for the laser test. And then Jaron says no, because he's part of the committee there. And he said, no, they're going to be there on the 20th, but their website said the 14th is all. So they're supposed to be out there now for 2 weeks waiting for the weather and to do these tests to see how far they can shoot that laser and look for curvature. But I guess in their early test on their early test where they went out and did a quick test to see how the laser operated, I guess they had seen it like 14 miles away, and it was at ground level when they did the test. So that right there should be an indication of it's flat.
Yeah, it's definitely flat.
I still remember that Bugs Bunny cartoon with Christopher Columbus looking to sail the world to prove that the world is round, and the king's like, no, the world is flat. And he says, no, the world is round like your head. And the king takes a big hammer and smacks him on the head. It's like, no, it's flat like your head. I just remember that cartoon from Bugs Bunny. I see somebody finally put it on a channel somewhere with a little clip at the beginning showing that. Hitting Columbus on the head with that mallet and making his head flat. No, it's flat like your head. I always remember that from a kid.
Very funny.
But yeah, they were heckling us for years and years. Even back then, that was all propaganda to make you believe that if you think the world is flat and you were a kook, I had to pound it into your head that people thought the world was flat. How stupid they were. They pound that in your heads all your lives.
Yeah, stupid, are we?
I red pilled a guy today and told him the world is flat, and he's like, what? Looking at me all strange and everything. And then I found this little it was badges from different countries, and it just so happened to have like many different kinds of UN badges. So I said, these places, yeah, where are they on the earth, like, yeah. I said, what about this map? And he looked at it. I said, there you go, that is the United Nations map shown from the North Pole. Oh, there's another map shown from the North Pole as well. Oh, and another one shown from the North Pole. I said to him, it's flat. Look me in the eye. It's flat. Go home and research it, man. Yeah.
The latest,
So,
the latest map I saw was someone put it in a video. It was from John F. Kennedy's airplane. He's sitting in the seat, and on the bulkhead behind him was a different style of a flat Earth map. I'd never seen that one before, but someone found that and posted it on YouTube video. And it was a little different looking, but it was pretty much the same as the UN map. But it was close, but it was different. But I thought that was pretty interesting when they brought that out.
isn't that similar to the map where, I don't know if you've seen it, by the way, but Richard Byrd, he's also shown somewhere, and in the background there's one of those maps.
Wasn't that from his
It's in black and white.
Yeah, that was from the one video interview that he was doing where he said
the
that
Longines.
there was land out past the thing that's been unexplored, land that's they had that map on behind them too.
Yeah, wasn't that similar to the JFK map? That was my thought, that it was similar, if not the same.
Yeah,
I don't know.
I'm not sure. I'd have to compare the two. I only seen that video once, and I don't even know if I could find it again. I've got so many videos in my history, it'd probably take me a day to find it, because there's thousands of videos.
If not a month. If not a month.
Yeah, months. But that video was just recently that I saw that. Yeah, that one was just within the last week or two that I saw that video with JFK. That was interesting. Yeah, looks like the wife just came home. I just turned off my Wi-Fi because Go ahead.
We've been going for 3 hours now. We try and keep the hangouts to about 3 hours. With your wife coming home, it might be just the right time to sort of.
Yeah, that's okay. I was just gonna say, my router for my internet access, we use Wi-Fi, so I turned the Wi-Fi off so my phone wouldn't try to connect because it will automatically want to connect to Wi-Fi first. So I turned the Wi-Fi off, and I was going to turn it back on for her when she came home. But since I'm on my phone, I'm not using the Wi-Fi is all. And so far it works good. Because on the Wi-Fi I can't use video.
That's pretty good for an American Wi-Fi.
And this phone cost me $10. It's a Sprint pay-as-you-go phone.
Oh,
I bought this through. I bought it through Sprint, and it was only $10. It's a Android. It's an LG phone, but it was only $10 off of the website.
And it worked.
Seems to take pretty good video.
Yeah, it's not bad for a $10 phone.
Yeah, it's a throwaway, and it's over a year old already.
Yeah. Anyway, Don, we'd really like you to come back and tell us the progression of this aeroplane that you're building.
Sure.
I think Astral would really like to hear about it, wouldn't you, Astral?
Yeah, I'll be working on it all summer long. If you when you subscribe to my channel, if you get any notices every time I put a video up, 9 times out of 10, it's going to be about that airplane. So I try to make them every week or every 2 weeks when I'm really doing well on the project, where I'm seeing a noticeable difference. I like to share. Plus, there's so many other builders out there building this types of airplane, and nobody has any videos of it. No pictures, no videos. So I just want to make a library for any fellow builders like me that will help them out and give them ideas. So that's the whole idea of documenting what I'm doing now.
Yeah, and we very much appreciate it, and we think you're a very clever man. So I will email you and ask you to come back, Don, in the future soon. We'll ask you to come back.
Yeah, no problem.
We very
definitely.
Yeah, well,
Artist,
I appreciate the time.
Artist was having quite a lot of problems. Artist, you're muted. He's not unmuting. Oh, he is?
Can you hear me?
Yeah, you're a little bit faint at the moment.
Well, it was indeed very, very interesting, though. Very interesting. I'm looking forward to see your other videos of the continue on the building of the aeroplane.
Yeah, artist wants to know how your project's going to go as well.
Yeah, I
Um,
could just barely hear him, but I just caught what he was saying. Though I did hear him.
Yeah, I turned him up full to the full thing on the panel. I'd like to say thanks very much to everybody that's been on this panel today. That's who else has been here? Levkungfu, Jay, Yudit, Astral, Patricia, Artist, and our special guest Don. So thank you so much. We're back tomorrow with Matt Jerome tomorrow evening. Anyway, once again, thank you so much, Don. That was really great. That's really interesting. And yeah, good night from us. And thank you to everybody
Okay.
in the chat.
All right. Yeah. Thank you very much, and good night, everybody.
Good night.
Nice to meet you
Yeah,
all.
good night, everybody.
Thank you,
Thanks, Don.
And also thank you,
No
Karen.
problem.
Oh, thank you. Thank
Yeah,
you,
thank you,
everybody.
Karen.
Thank you. Thank you, Astral. Thank you, Artist. And thank you, lovely chat room.
See you guys.
Anyway,
Alrighty. Catch you guys later.
bye.
Bye bye.